Alright, it is 1:30, so let us get started. Just a quick show of hands. How many of you are here for the first time? Not anybody? Okay, awesome. So we are having a bunch of repeats for the last couple of times. That's always good. Excellent. So last session we actually spent some time focusing on the over design. I know we only did one question, we didn't do the other ones. So what we'll do is next session we'll actually do the remaining ones. And I think there was one request to do the chat server thing, so we'll end up doing that. And I'll touch upon the others as quickly as we can so that we can cover the basics. So we'll do that then. For today, I think the focus, I wanted to continue to focus on what we had as the main course, which was the recursion and dynamic programming. We have a bunch of questions, so let me see if I can time it appropriately. Don't want to go too deep. At the same time, I also don't want to keep it as I want to cover enough depth. All right. So how many of you have actually solved the questions? Okay. Awesome. So it's way more effective if you've actually taken the time to solve it, and you've taken the time to read through it, because it's a lot more. What we'll cover here is different techniques and whatnot. Your goal is to actually figure out like where you got stuck, why did it take time, and then you need to figure out what actually got you to get past that point. So that's kind of where the learning is. So let's get started. So the first question that we have is the triple step question. Any suggestions on how to solve that? So the question as such is apparently the question is that it's done in many different ways. One of them was essentially you've got steps, and a kid can actually either jump one step down, or can jump two, or jump 3 steps at a time, and that's what the kid can do. Or once the kid comes here, he can still do 1, 2, or 3. It's up. All right, so the kid go up.
Despite the fact that their solution goes downward.
All right. Whatever the case is, so
Still the same solution.
the goal is essentially to go down the steps and find out how many unique ways can the kid actually make to the destination. If I were to rephrase it in a different way, if the total number of steps is 100, how many ways can you actually say, I will take 1 step, then I will take 2 steps, then I'll take 1 step, then I'll take 3 steps, then I'll take 2 steps, and so on. Let's assume that adds up to 100. Perhaps I might take a 2-step. The easiest way I could think of it is I could just do 1 plus 1 plus 1 plus 1 plus 1 100 times. That's one thing. I could do 2 plus 2 plus 2 plus 2. That's like 50 times. I could do 3 plus 3 plus 3 plus 3, and then I have to probably do a plus 1 to make it 100. So I could do all of that. So there are like 3 different ways I can do it, and each of these combinations is sort of unique, right? So the goal here is to find out how many unique ways can you do the 100 steps. And how do you get that?
So the coding and people try to do this, they don't present this solution 100%. The most obvious solution, and which unfortunately is very inefficient and requires a lot of space, is just calculate all of them and then find the one with the big most defined, and then just count them. Right?
How would you do all of them?
It's fairly easy, right? You start like any set of combinations, right? You start with going up 1. It's fairly straightforward, but not trivial. But
So
there's a variety of ways to do it.
there
Right?
are 3 things you can do at the get-go, right? What can you do? I can either take 1 step, or I can take 2 steps, or I can take 3 steps, right? Then once I'm done with my first step, what can I do?
Then you can
I
either
can do
take
3 things. I can do 1 step, I can do 2 steps, or I can do 3 steps, right? I need to leave some space, right? So plus 2, plus 3. After I've taken 2 single steps, what can I do? I can do 1 more step, I can do 2nd, I can do 3, and so on, right? So one of the easy ways to, it's just mine, you can move it. So one of the easy ways to actually think of this is that, hey, so for the first step, I can either do a single, double, or triple step. For the second step as well, I can do a single, double, or triple step. For the third step, I can do a single, double, or triple step, and so on. There's one place where this breaks up, which is
Dynamic programming.
say again?
Dynamic programming, you can use dynamic
You
programming.
can use dynamic programming, but why is this approach or this technique actually breaks? Because the number of steps that you will need to take is actually not fixed. in the sense that the number of moves you make, right?
Oh, yeah, you have to keep adding,
So,
you can't replace.
Unfortunately, if you have a scenario, if I were to say that, how many ways can you have like a deck of hands? Like if you have 10 cards in your hand, how many different combinations of hands is possible? Your first card can be 1 of 52. The second card, 1 is gone, so 1 of 51. Third card is like 1 of 50, and so on, right? And you can reduce it, and you can reduce it, but the number of cards in your hand is fixed, so it's a lot easier for you to mathematically compute that, right? If I were to say that, you know what, it's not just one deck of cards, it's like, let's say it's like 100 decks of cards. Then you can say, you know what, my second card can also be 1 of 52. My third card can also be 1 of 52 in that case, right? Only 52, because it doesn't matter whether you pick the ace of spades from the first deck, the second deck, or the third deck, but here the goal is that since it's only one set of, like the number of cards in the hand is fixed, it's a lot easier for you to mathematically do that. Why can't you do that same thing here? Why can't I say that I can take my first step in 3 ways, I can take my second step in 3 ways, I can take my third step in 3 ways, and so on. Why can't I use that technique here? It's because the number of steps is not, number of moves is not defined.
Right, well, the way I did it was, as you build, when you start with 1, 2, and 3, you have to see if you made it to n yet.
Mm-hmm.
And if you did make it to n, then you add that one. If you made it over n, then you get rid of that one. And if you're under n, you go on, basically.
So you cannot like use permutation combination techniques for this one, but essentially what you'll have to do is that you'll have to enumerate each of them and then figure out if you're reaching the end or not. It makes it a lot harder. Okay? So that's why this is difficult.
Can we think about it in this way, like suppose 100, so what n? So to reach n, we have to find all the unique ways to reach n. So it will be 1 plus all the unique ways to reach n minus 1, and n minus, actually not even 1 plus. It will be just all the unique ways to reach n minus 1 plus all the unique ways to reach n minus 2 and all the unique ways to reach n minus 2.
Yes, that's the book the solution does, but it's not intuitive.
So,
But if I reach n minus 3,
right.
I can still take a double jump and a single
Yeah,
jump, right? So how does that work?
But that is already counted within n minus 1 if you take a double step.
So aren't you duplicating?
No, because I'm taking only one direct step from n minus 3, right?
You're talking about that is the key. I was just
We're
talking
talking about
about
the
that.
book solution.
So essentially,
I haven't looked at
And the book solution, yes, works like a Fibonacci problem.
so the way
They're going backwards.
to think about it, forwards or backwards would work roughly, wouldn't change the equation, but it's saying what's the first thing you can do? I can take one step, right? That's what we said, right? Now once I've taken one step, let's assume that you have the function which actually says, let's assume that f of n represents a number of ways you can actually do f of n, okay? So so f of n is essentially, if you take the first just like a single step, then how many steps remain? It's essentially f of n minus 1, right? You've got one step. So essentially, if you take one single step, you've got n minus 1 steps to go, and this is the number of ways you can solve that. So you take essentially what I call the single step, and then you do that, okay? Or you can do a double step, and you have n minus 2 to go. Do you think any of this will overlap with any of this?
Yes.
Absolutely it will.
It's just like
But do you think any of this will overlap with any of this?
Yes,
Yes.
yes.
Actually no, because since the first step is single in this case, the first step is double in this case. So every combination that you generate here will be unique, because it's essentially what you've done is you've done 1 plus something, something, something. And here you're doing 2 plus something, something, something. Even if this were to be 1 plus 2 plus something, and even if this were to be 1 plus 2 plus something, this and this might be the same, but if you look at the total combination, it's always unique. Why? Is because every combination here begins with a single step. Every combination here begins with a double step. And every combination here will begin with a triple step. Okay? Right? So far with me? Okay? So if I were to actually, on top of this, if I were to add like the mechanism that that the kid can do like jump to the end as one more option, right? At any point of time, the kid can choose to jump to the end. You can't take a 10 step, you can't take a 15 step if you want to, but what you can do is you can say, I want to jump to the end at any point in time. So I could do a 99, so you could do a single step and a 99. Could do a double step and a 98. Could do all of that, right? All I'm saying is I'm just like taking this question and just adding one extra condition, which is saying I can do a jump to the end at any point of time.
Which I think would destroy the book solution.
Of course. So it changes the equation, but sure. How do I deal with that?
But
Which means you're given like one arbitrary jump, which is essentially gigantic, and that has to be towards the end, basically, right?
It can be any steps. Jump can be any steps at any point in time.
It's any number of steps. So you can do a step which essentially says jump to the end. And you can only do it once, obviously, because you'll reach the end, right? So how would you change it? So let me actually finish this first and then we'll come back to that, okay?
Yeah.
So the number of ways of doing this is essentially the number of ways you can do this, plus the number of ways you can do this, plus the number of ways you can do this. So that essentially will work out to f of n minus 1, plus f of n minus 2, plus f of n minus 3. And that works because it's this way, plus this way, plus this way. The number of ways you can do this is n minus 1 ways, f of n minus 1 ways. Number of ways this can happen is f of n minus 2 ways, and f of n minus 3 ways. Hence it's that. If the triple step didn't exist and it was just like single and double steps, then this would essentially not be there, and this is essentially your famous Fibonacci series. So this is kind of like one step on top of Fibonacci, that's all. And you could try it out mathematically and see how that works, and you could take like 5 and try it out, and then you will probably see that this works. Okay, so any questions on this before I jump
So you
into
could just like Fibonacci, you could do what they call memoization. To create an array and store it in these.
For Fibonacci, it's still the Fibonacci. It's still the same thing.
You're just adding up numbers.
We're not doing that.
Yeah, we remember that first we have to take one single step, then f minus 1, right?
Correct.
There we have given only f minus 1.
So how many? So let's assume that there are like 150 ways you can do this, right? For just argument purposes, 150 ways you can do this, 90 ways you can do this, and like 35 ways you can do this. Okay? Obviously they're not the right numbers, but sure, let's assume that that's the case. How many ways can you do n steps? So if you know that there are 150 ways to do f of n minus 1, then you take one step, and then each of the 150 is a solution for this,
Yes.
right?
Yes.
So there's only so the answer for this is 150 plus 90 plus 35. That's it.
Okay.
Because what we are computing here is not the number of steps, but we are computing is the number of ways the steps can be taken, right?
Right, that's the other big advantage here is you save a lot of space.
Mhm.
Because my solution, you can actually generate.
You have to generate all the combinations
Right.
and get there.
Right.
So
So you-
which is not a bad answer. I mean, it is an answer anyways because it is functionally correct, but it won't get you to the answer quickly.
How about step 0? Like, can we, I'm confused, like, can it be 1 or should it be 0?
There's no
F of
steps.
0.
There's no steps.
F of 0?
There's no allowing.
So
Yeah.
that was a question that was, so if what is f of 0 in that case?
Because
Undefined.
If you have, if there are no steps at all, how many ways can you actually, reach the finish line? You're already at the finish line.
Yeah.
So do nothing is the answer. And if do nothing is a way of doing it, then you could say that the do nothing is
in 1.
1. Or you could say that, there's no steps, no way, so no. So it depends. In an interview setting, I would, if there is a requirement to, pick f of 0, then I would actually, my first goal would be to say, the input cannot be less than 1. I mean, I have to have at least 1, because 1 I can take in one way, 2 I can take in 2 ways, in this combination and so on. The only thing to note in that case is that your f of n minus 1 is not defined, f of n minus 2 is not defined. You need to figure out what your termination conditions look like. But that's
Right, you have to, right, for the mathematical case, you do have to have an f of 0 and effective f of negative.
f of negative 1, f of negative, they're all zeros essentially for all mathematical purposes because they're not really adding to anything.
Or the f of 0 actually, it's easiest to use 1, mathematically speaking, so that it all works out. Otherwise, you don't get your starting point.
The f of 1 would be 1. Fibonacci series starts with, if you look at Fibonacci, it is 0, 1, the first two Fibonacci numbers. F of 0 and f of 1 are 0 and 1. So that way, that's how it goes to 1, 1, 2, 3, 5, and so on.
Yeah, the book does f of 0 is 1. You could do it either way, you just have to judge.
It is a clarification thing for your interviewer.
One more question. When we are in 99th step, and I want to take only one step, or even two steps also valid?
No, you can only take one step.
Only one step.
Correct.
Okay.
But what I was saying is that for zero, that for mathematically, for the mathematical sequence.
That's a good point. I'll come back to that in a second.
Sorry, for mathematical sequences, there is no such thing as
Fair enough.
steps.
Absolutely.
So
So
for the
the
public
one,
method you call, it should.
yeah, the one thing that he was actually talking about was that, am I supposed to reach the 100th step or can I go beyond that?
Yes, that's okay.
Right?
And the answer is
So-
you cannot.
In this case, you cannot.
Right.
But then the question will be, if you can, how will you change this question? So in an interview, typically what happens is, the expectation is for you to say, hey, think about the problem, solve the problem, have the right construct, and then we complicate it a little so that we just try to see whether you're actually repeating a solution that you've already heard, or are you extending the solution that you know. So that would be a very good extension to this question, where you would say that, what if I, instead of this being steps, right, what if this was like a, I don't know, like a sack race or something, where I'm starting from here, I'm finishing here, I could jump like 1 meter, or I could jump 2 meters, or I could jump 3 meters from any point of time, and my goal is to just finish the sack race, and it's 100 meters of jump. So which means that theoretically from 99, if I do a triple jump, I'm still good, right?
One good thing about the thing I talked about with the brute force way of calculating them all is it's very easy to adjust for all these conditions. Because
Yes.
they're already there. You just have to tweak the code a little bit. You know, there's one line where you drop it if it's over past n. You would just keep it as past
Yep.
n.
So the repetition, the brute force, is makes it a lot easier because the conditions are evaluated. So you could potentially tweak one condition and make it work. A lot of these simplifications are based on the fact that you're solving in different forms. So I'm not going to solve that extension case. It's a little more long drawn, but you'll have to essentially break it down into different scenarios. The thing that you have to figure out is you need to not only reach 100 exactly, but you actually are expected to also reach essentially 99 and then do a double step, or a triple step, or then you have to reach like a 98 and then do a double step or a triple step. And so you have to think through how it'll actually work and break it up into specific parts and then add them up. It will not be this formula, but it will be something else.
Could we like, think about it like n minus 1, n minus 2, n minus 3, okay, it won't be the same. So can we say that,
We're not solving that problem here. Okay, so work it out and then we'll get to that. What I'm curious about is actually to solve the other problem where I was actually saying that what if you could actually do jump to the end. So these are different variations and spins that an interviewer can apply at any point of time. And your goal now is to, if you solve this the right way and if you have the right construct to actually get the problem going, I expect you to solve it. So the expectation here is, the question here is, the kid can essentially, I mean, since it's let's say it's rolling down the steps, right? Can actually jump 1 step, 2 steps, or 3 steps, or the kid could just like choose to jump all the way to the end in one shot, right? So if you could do that, what does the formula look like?
You will solve it at the end and add n to it because there is only n ways to each n.
Say that one more time.
We will get the answer normally through recursion and you add plus n at the end because there are only n ways to reach it in each step, right? You get the answer, right, in normal recursion, you add n to it, n minus 1 ways to reach the n.
Are you sure? I like how you're thinking, but that may not be entirely true.
Because from each step you reach at the end, right?
Correct, but how do you reach that step?
You have
So-
to double it, right?
How do you reach that step?
You said that you can jump at the end.
No. So
No, you
let's
don't.
assume that from 50th step the kid has chosen to jump down. Okay? How did you reach to the 50th step? How many ways can you reach the 50th step?
Using the formula.
Huh?
Using the f of n, and you add 1 if n is not equal to 1, 2 or 3.
So
yeah.
so let's break it down and then start from there and let's see if it. I see what you're saying.
But I think
My
it's,
instinct says that it's not the case.
No, I think what I think
one
you
single shot.
You can't reach 50 in one single
But
shot.
you can reach the end, right? So you
So,
can shift.
Let's take
you would
2, right?
figure out whichever ones at the end are not on 50.
Can I start with this? Let me just take the f of n. What you can do is you can jump to the end straight
Yes.
in one way. Okay? Then you can take a single step. This is a jump case. Okay? then you can reach using a single step, okay, and you can reach using a double step, or you can reach with a triple step, right? Hang on, okay? Yeah, so you can do that. However, this is only possible
For the
if
last step.
n is greater than 3. If n is less than 3, then if like n is 1, right? Then it's a single jump case. These two are identical, so you don't want to do that. If n is 2, right? Then this is a double jump case anyways. Like that step will be included in the double jump case anyways. So you don't want to include that. If n is 3, then that's that, you don't want to include that. So now, in my opinion, this is what this will essentially be, which is f of n is equals essentially 1 plus f of n minus 1 plus f of n minus 2 plus f of n minus 3, and this 1 is essentially, I'm going to only add it if n is greater than 3. If I did this, I get the answer. And this 1, unfortunately, will get added thrice. Right? Oh, and it's added multiple times, so it's not just the old formula plus n. It won't be. Okay, let's go to math it out.
So it becomes n minus 1 3 months at the end, right? That's what I'm saying. So you get the recursion plus n minus 3. Because the 1 gets added n minus 3 times.
No? Why? So what is f of n minus 1? What is f of n minus 1? F of n minus 1 is actually 1 plus f of n minus 2 plus f of n minus 3 plus f of n minus 4. So it's 1 gets added because of this, and 1 gets added because of this, 1 gets added because of this, and in addition to that, each of that, this will also have extra 1, this will have an extra 1. So there's the number of 1s that get added. This is that Fibonacci tree, right? So you will get this 1 will get added multiple times. You might want to try it out as a simple math. Write the formula, write the function, try to see how it actually runs. And what I suspect you will see is that this is not just as simple as trivial as just adding. If I were to just do that, it's not enough.
So from any step we will get one extra chance, right? Except that
There are 4 ways to reach the end from, not 4 ways, like 4 sets of ways you can reach. One is essentially by doing a single step plus this, double step plus this, triple step plus this, or like a full jump, right? And that full jump is only available to the person if you are in the 4th step or above,
4 and
because otherwise it's going to be encompassed the same thing that you have before, right? So what is important here is to start thinking of this question more in terms of first principles. Think of like how are you actually breaking it up. So the big difference was this. Now if I actually were to say, instead of it being 1, right, if I were to say that the kid can somehow like do a half jump, which means that if there's 100 paces to go, I can only jump half the distance. If there's 50 paces to go, I can only jump half the distance. If I did that, right, how does that change the equation? So the question makes sense. If the question were to be saying that instead of, like, I can take 1 step and then I can, at a time, I can just take 1 step, or I can take 2 steps, or I can take 3 steps, or I can actually jump half the distance between me and the finish line, rounded down. So if there is 9 meters to go, I can only jump 4 meters. If there is 8 meters to go, I can only jump 4 meters. If that were to be the new construct, how would you actually solve this?
With that, you replace by n by 2, and your n greater than 3 condition would be n by 2 greater than 4.
So this would be replaced by what?
N by 2.
Just n by 2?
Function of
No, function of n1 over 2. Function of n over 2, and the condition of n starts at 4.
Because after you jump the half, right, then you need to still solve the remaining distance in f of n by 2. So it will become f of n by 2, and this is like essentially floor off. Floor is automatically assumed because it's integer, and this is only permissible if
n is greater than 4.
which is essentially if essentially so if it's 7, what do you do?
Oh yeah, that's another problem. Yeah, so
Yeah, you can see
3 and then
yeah,
plus
yeah. I mean, that's
8
the question.
is permitted because so this floor of n by 2, right? this cannot be 1, 2 or 3.
Right.
It has to be more than 3.
Right. Yes.
Only then this is valid. Otherwise it will be folded with the other options. So, I mean, I can keep coming up with infinite variations of this, right? It's not a big deal. From an interviewer standpoint, it's pretty easy. What, again, the intention is not to pick apart this one question and learn how this one question works, but the intention is to actually break down the thought process in terms of how are we actually doing this? How are you actually ensuring that there are no duplicates? You are ensuring no duplicates by, I'm taking X number of steps, I'm taking a step X first, and then I'm actually solving for the remaining. So that's how you did it. And then, depending on what is given to you, you can actually apply certain things. The key factor to remember is that you don't want any overlaps in that, which is why the condition of n greater than 2 or n greater than 8 or n greater than 3 or whatever that we did, if you don't do that, then that will overlap with one of these combinations. If you have 6 steps to go, and the f of n by 2 jump you did is like you did a 3 jump and then you're trying to solve for the remaining is identical to this case. So you can't do that. Okay?
One question, in point of view. For example, if I am taking more time to solve the first problem itself, and another case I am solving first problem efficiently, more quickly, and when the interviewer asks the follow-up question, I am struggling. So still it may be same way I will be evaluated, or because of the follow-up question, it may give some negative impression. Since I've been solving.
So try to work it backwards from the interviewer standpoint, right? So what does it mean that you got the first question quickly? What does that mean? That you've seen that question before. Okay? More likely than not. Or maybe you're like smart enough to figure it out or whatever, right? And I'm making an assumption that you're actually explaining how you did it. Because if you didn't explain how you did it, then I'm going to assume that you already knew it and whatnot. But let's assume you explain everything. Now I don't know whether you arrived at it or whether you knew it. I don't know yet. Now I do the second question and you don't answer it, so what am I going to assume? I'm going to assume that you knew the first one or you've seen something similar and you don't have enough like knowledge or skill to actually extend that logic into the next one. So the one of the common questions that I get asked is like, is it better to actually in an interview, should I get a question that I already know or would I prefer a question that I don't know, right? It's a very classic thing that you ask for. Actually, it is better to get a question you don't know. Because then you actually will go through the process of building the question, the answers to the first principles. You have enough material available, and you should be able to follow up with anything the interviewer throws at you. So that is that. Okay. So from an implementation standpoint, it's actually fairly straightforward. You could implement it using like straight up iterative technique for the question that is given, or you could use like some sort of like caching, or you can store it. Memorize it, as they call it, not memorize it.
I think they made that word up.
It's from the memo, is memoize, as opposed to memory, which is memorize, and both are applicable of sorts, but they choose the other one.
I spell check every time I did it. So.
Alright, so let's go to the next one, which is power set. I accidentally, I didn't know how to add 3 to a question, so I did 8.3 as well in the Facebook when I was just trying to do that. So, alright, 8.4. Which is essentially power set. What is a power set?
Set of all sets.
All possible combinations of any given set.
Mm-hmm. And how do you get to that?
Like if you have ABC, it's like MP, A, B, C, A, D, A, C.
So if I have a set which has like just A, B, let's do 2 things, then the power set that has these 2 is essentially represented by
Empty set.
empty included.
A, B, A, B.
And is that it? So all possible combinations of, or all possible subsets, all possible sets where the set is a full subset of them. So essentially it could be that it's identical, or it could be missing 1 element, or it could be missing 2 elements, or 3 elements, or whatever it is, right?
Yeah.
So how do you go about doing that?
Generate, like, you can do it like using binary 2 for n and generate all the possible combinations and denote a 1 with an element inside the original set.
Mm-hmm.
Yeah, that's the more complex solution.
The binary solution is before we go there. How many of you actually attempted this question? You want to keep asking this question, at least in the hope that next time you'd want to raise your hand. Alright? Alright, so thank you. So how many of you did it using the binary technique, or how many of you are like comfortable with the binary technique? So the binary method is actually, it's not the intention, and I'm not really very sure if the binary technique actually is helpful. I mean, it's the most efficient way of doing it, most effective. The fact that you know how to do it using a binary technique may or may not be enough. It's a fantastic way, given that you have like n elements in a set, right? The power set essentially depicts all of the scenarios where you can have every element in it, or none of the elements in it, or every combination thereof. So if you define an n-bit number, so in this case a 2-bit number, which is essentially 0, 0, 0, 1, 1, 0, and 1, 1, and this represents the presence of A and this represents the presence of B. All binary numbers from essentially 0, 0 all the way up to 1, 1, every combination, if you map it, they will map to this, because this represents a set that contains neither A nor B, which is essentially null set. This contains B but not A, which represents this case. This represents A not B, which represents that case, and this represents both A, B. So, fantastic way, super smart, super effective, super efficient. I don't expect you, if you didn't know, I don't expect you to get this in an interview right off the bat. But this is a good technique to know in case you have a question that actually builds on top of this. Then this becomes a very effective tool for you.
It's just tricky because you have to do all the basic.
Not a whole lot. I mean, it's
Not a huge amount, yeah, but
it's just you would run a loop from for I equals 1 to 2 power n minus 1, and then for each one will just represent the set, and I should be able to, given any number, I should be able to generate a subset of a parent set based on the number that's given to me. That's a very simple client function, and as long as you can break it out, you'll be fine.
Would it work for the range out of binary, like after 64-bit or like 32-bit? Like if an array has like a...
these are arbitrary constraints. So if you have, if you do the binary question, the interviewer is bound to come back and say, what if, right? Binary is, what is your answer to that? What if I use big number? And then just use that, right? At the end of the day, my goal is to generate, how many subsets are there? It is precisely 2 power n minus 1, right? Or 2 power n actually, because null set is also. So essentially from 0 all the way up to 2 power n minus 1 is what we're trying to get to. So there are 4 combinations, 2 power 2 combinations in this case. So I would be generating all the numbers from 0 all the way up to 2 power n minus 1 in that case.
How does it depend on any data type? You're not using the data type, right?
What if I give you a set with 200 elements in it?
Yes.
How will you generate a binary number which is size 200?
I'll just create an array of size 200 each, and I'll be placing integer values which are only 0 and 1 inside that.
So you are reconstructing an arbitrary size binary digit number using this, which is essentially big number gives you that anyways.
right, it's fundamentally different than using a binary.
You're not using the fundamental integers that's given to you, but you're actually using the same technique. So nothing very complicated. I mean, the integer length is an arbitrary construct. You can easily get around that without much of a hassle. So, I don't want to spend too much time on this specific aspect of it. The bigger angle here for you to think of is using the basic principles of recursion. Generally, your goal is to, if I have a problem with n, I want to actually find out if I can make it a problem of n minus 1 and make it work with that. So the way I would do that is essentially, I want to say that if you give me a set of size n, right? So my goal is essentially to say that I would like to take the last element or the nth element there, and then if I know how to solve it for a set of n minus 1, right? Then what I'm going to do is that solution, if I just repeat that solution again, and for every element in the set n minus 1, if I were to just add just the nth element to it. So none of the combinations here will appear here, because like every combination is duplicate and I've added n, so everything will be unique. And this should get me the same answer. It's not, the binary generation is all like, fantastic and cool, but here this is kind of the fundamental breakdown of like, take a problem, try to solve n minus 1 out of it. Make sense?
Yeah. So you're doing one where there is n and one when there is no. Okay.
So solve for n minus 1, and then solve and then add when there is n and in the very trivial case, if there's only one element, then this represents the null set, and this represents the first element.
Can you go the other way? Also start with the null set and add elements instead of back?
Yeah, build up and tear down. So this is like the top down approach of like where you're actually tearing down. The reverse, you can do the reverse as well, where if I know how to build like n, I know how to build n plus 1 is what I'm trying to get, right? It's a lot easier in the recursive stance. It's much easier because then you can build it and keep the termination condition and you're golden. So here it's the same thing. So if I know how to build a set of n elements, how do I actually build set of n plus 1 elements from that? It is the same thing, right? Essentially I am saying I take set n, I will replicate it, and then I will add the n plus first element to this one, and that's how I build up, right? In the trivial case where n is 0, I'm going to start with just an empty set. So actually the formula is identical. It's no different if I were to represent it
One
mathematically.
advantage I see from building upwards is that if you don't use recursion, I think the build upwards lends itself much more obviously to iteration.
Yeah, of course.
And it's a fairly easy iteration. It's actually, in my opinion, the build up is more naturally iterative than it is recursive in a lot of ways, in my opinion.
This would be an iterative approach built up, where you start with 0, you keep adding elements to it.
Right. But you could do it either way.
If I change the question to say this is not, let's say it's not set. Set defines uniqueness, right? Let's assume it's not a set. It was not a set. It was like a list, collection, or something else, right? And my goal was to essentially, I'm trying to figure out what's the best way to explain it. It's like, let's assume that I have like coins. I have like bunch of coins that I have, and my goal is essentially to collect a set of coins, and the coins that I'm collecting, that pattern should be the same. So which means that if I have, in the simplest form, let's assume that I have like 10 pennies, and then I have like 10 quarters. That's it. I've got 20 coins with me, but I've got like 10 pennies and 10 quarters, right? And if I had to pick 2 coins from this list, what can I make? I can make 2 pennies, which is essentially 2. I can make 1 penny and a 1 quarter, that's 26. And I can make 2 quarters, that's 50. That's what I want to do with this, right? Or I can make, since it's a power set, I can also do 1 coin business, so it doesn't have to be 2. So I could do 1 penny, which is 1. I could do 1 quarter, which is 25. Or I could do nothing, which is 0, right? So if that was my question. Subtly different from what we have here. How do you now do it? The binary question now goes out the door, right? The binary one specifically works for what we indicate. So no more binary.
So we can just take each as one entity, right?
Hang in there. Go ahead.
So the set is mixed set, or it's like first we have 10 pennies and then 10 quarters?
It's not a set. It's no longer a set. The initial part is no longer a set. Okay? Even the output is no longer a set. Right? Repetitions are allowed. I'm asking you, given 10 pennies and 10 quarters, which is like 20 coins, I'm asking you to pick at most 2 coins. So essentially you can pick no coin, 1 coin, or 2 coins. Tell me how many ways you can do this uniquely. If I added the uniqueness constraint everywhere, if I said the coins were originally unique and the output also has to be unique, then that is this. Okay. But if I eliminate the uniqueness constraint, then how do you deal with it? Does that make sense? Anyone has any questions on the problem statement? Alright, go ahead.
No, I don't have a question.
Go ahead. How do you solve it?
So, in one iteration, we can try and figure out how many distinct entities we have. Like penny would be one, let's say A, quarters would be B. So in the first iteration, if they are not given as a collection of each, then we need to iterate once and figure out how many are unique and then do the same thing.
Restate that as a recurrence formula. Like, I am trying to solve for n. If you knew how to solve for n minus 1, how will you build that up to solve for n? And what is n here?
Number of combinations.
Number of left coins.
Number of combinations.
Number of coins left, so there are 19 coins left.
No.
Number of coins left to pick.
No.
Sorry, like,
Left to pick is 1 in this case. If I pick 1, then I have 1 more.
Yeah.
no, so you have, yes. So you said you want to pick 2 coins, right? So
That may not be entirely helpful, but I like where it.
Why not? Why not though? like you start with 2 coins, and then you for every choice of coin you have, you go iteratively.
So here is essentially there are essentially k n coins in this case,
Yeah.
and then your goal is to pick at most k coins.
Okay.
That's what we have, right? So now in this case, I'm hearing that you're going to say you solve for k, assuming you can solve for k minus 1.
Yes.
That's how I'm hearing, right? That's what I heard.
Yeah.
The fact that I use n, I don't want to
Right.
tempt anybody to think anyway. There are some challenges here. How do you figure out the uniqueness? How do you make sure that the solve for k minus 1 does not step into the solve for k? So this is in some form a different example of this is like the change making. It's almost identical to that. So, but it's in a different form. In the change making scenario, your goal was to reach a target change, right? You have to reach $100 given $1, $5, and $20 bills. In this case, the goal is to actually get k coins, and the target sum doesn't matter in this case, right? So, take a step back.
Yes, so the way I was thinking it is like if we have 2 sets of coins, like 10 pennies and 10 quarters, like if we consider pennies as A, so we have 10 A's and 10 B's basically. So I just
That's a
sort them.
trivial example, but you may have 10 A's,
Yeah,
10
yeah.
B's,
And
50
it
C's,
can be
20
anything.
D's, doesn't matter.
So
Okay?
the way I was thinking is that first we have to sort that list so that in the recursion I can take care of making a check of the next element. If it is same as the previous, then I keep skipping so that I don't pick the same coin again. And if I find a different coin, then I pick it so that it solves for k minus 1. Picking up a unique coin at that point.
It's fair enough. Restate that in the form of a recurrence formula.
You have to say how many coins you've already selected and then.
So the number of coins you've already selected is k minus 1, right? If you know how to solve for k minus 1, then how will you solve for k from knowing from solving for k minus 1? Like I can add. What do I add to this? How do I know what my pool of currency left is?
So think of like that input as kind of like a map of coin
Key value pairs.
and yeah, key
And
value
then
pairs
okay, like denomination and
and number of
currency count.
units
Yeah.
available. So initially we need to like pick 2. We initially just go ahead and pick a penny, and then we go one step below in the recursion, and then we pick another one again. And each time we pick a coin, we need to reduce the number of coins left in our set.
So you are, one of the things you said was you're going to have coin A, there are like 10 of them, coin B, there are like 3 of them, coin C, there's 5 of them or something like that is what you have, right?
Correct.
That's what we have.
Yeah.
Okay? Now the thing is that this N represents essentially I want to solve for this entire thing, right? So how do you solve for this entire thing? So essentially solving for this entire thing is how many coins do you need from this? K coins? From that list, right? And pick a coin to pick first. What did you pick?
I'll have a loop.
You picked the A.
I'll pick
Right.
A first. Yeah.
So option is you pick an A,
Mm-hmm.
okay? And then you solve for is that what you're doing? Or you pick a B and then you solve for, this is not right, but or you solve for C you could do that. But what's the problem with this?
There's some duplication.
There will be a lot of duplication because in this solution, right, you will go and have a conversation where you will actually solve for k minus 2 with A9, which is essentially picking a B and then picking an A. And in this case, you will have a scenario where it's A9 and B2 and solve of k minus 2, where it's actually picking an A and then picking a B, and these two cases will be identical.
Why not like memorize this then? Like put them in certain.
Duplicates, as in you will have functionally you will have answers which you will be multi-counting. It's not a question of recomputing. You can, if it's a question of recomputing, you can always like memorize it. That's fine. But if this is more like you will be double capturing the output, and you will say that there are 100 ways of doing it, but in reality it's only like 50.
I mean, like if you find a duplicate there, don't count it.
That is also not fair. Then what you're doing, so fair warning in any interview option, when you generate duplicate combinations, never use a set, never use a sort to figure out and then unique it at that particular point in time. So don't do that. Like do not generate invalid combinations and toss them out. It's usually one is like it's bad practice, and second thing is the interviews will definitely catch on pretty quickly. Okay, so the way this is that I can do that, or I can do that. What did we do here? Yeah. Either my solution contains A or my solution doesn't contain A. If my solution contains A, then I'm going to solve K minus 1 combinations with the remaining 9 A's, and I'm golden, right? None of this solution will contain an A, correct? 0 A's, absolutely nothing. And I need to solve for K again. So what did I do? In this case, we went down by one number and we tried to solve a smaller problem. In this case, we went down by the number of denominations we're trying to solve for, and we retained the K. Right? This is actually akin to that change maker problem that we do. In the change maker problem, it was not K minus 1 and K, but where K was the actual value that you're going to, and the subtraction would be essentially the denomination itself. So here it will be you're solving for 100 minus 5 and things like that. So the answer is not as important as actually trying to apply the logic that we had. A lot of you were here when we talked about the change maker one. Even if not, it's a very standard question about how to make change. You should know that, and you should be able to take that and apply it here. It's exactly the same concept, exactly the same construct. It's very trivial to take a power set question and start with that. You knock it out of the park. The interviewer immediately go and say, you know what? Now let's assume it's all no duplicate, like multiple duplicates. Everything is allowed. Now what? I'm like, that changes the way of the problem. Let me actually go solve it again. And I'm going to apply something that I already know, which is how to make change. I'm going to just change that to use this. That is how I would expect to translate my knowledge of the change maker into this. Questions?
So that's it. I mean, now.
The answer is here. Yeah, it is answer, of course. But it is simple, right? Would it make a difference if I change it to A plus this, or if I change it around and call it B plus solve of B by 2, and then this had A10 here? It wouldn't make a difference. It doesn't matter what denomination you pick. Right? There are like essentially 3 different ways to solve this. You could pick A or not pick A, or you could pick B and not pick B, or you could pick C and not pick C.
Oh, this is the overall solution. Again, we will not have another condition for B, C, and D. So this is the final. If you are taking A, then we have to solve only K minus 1, or else we have to.
This will be the same equation. Like essentially, what you're trying to do is that this will repeat, right? How do you solve for this? How does this get solved? This gets solved by essentially you're solving for you're taking a B and then you're solving for B2, C5 and K minus 1, or you're solving for C5 and K. Right? So the same construct extends. I mean, it's just not. It's not always A and not A. It's like it's the first element in the array. You're taking it or you're not taking it. Okay?
How do you memorize it?
This will be the input. Your input is what you memorize or memorize in this case, right? Because there will be a scenario somewhere else where you will be computing. You may actually in this case you may not even get to that. But if you ever get to a scenario where your this input and that is actually the same, then you would actually repeat that. And this will only happen. In this case, it won't happen primarily because you're going down one coin at a time. In the currency scenario, it might happen because in the change maker, it will happen multiple times because the jump you make are different. So you may actually reach the same, I need to make $65 with 10 $5 bills and 3 $1 bill. I don't know how to make it. That question might come multiple times. Because how you paid for the other items before could be in different ways.
So how do you set up in this time, like let's say k is greater than 5 in this case? You let's see 5k.
You will not be able to solve it, so the answer will be 0 in that case. So it's essentially number of ways of doing this plus the number of ways of doing this, right? If you cannot do it with this, it becomes 0. In a change maker problem, if you have like a $10 bill left and you need to make like $17, regardless of how many $10 bills you have, you can't make 17 out of it. So that will be like, if you cannot make it, it will be 0. If you can make it, then it will be like just one way of doing it, right? So in this case, what will happen is you will solve of C5, let's assume that K was 9, right? So that is essentially would be, you're trying to solve of C4 of 8, solve of C3 of this, and it will go all the way, and essentially you will solve essentially C0 of 4. And at that point you're looking at, I can't solve it, so it will be 0, and that will just calculate all the way up here. But you don't have to specifically check. I mean, you could arrest that up front, but you don't have to do that. Okay? Alright? So, same base question. This is actually a completely different question than what we actually already had. 8.7 was essentially write, compute all permutations of the string of unique characters. Permutations of unique characters.
So, how do we define the complexity of these? Like, how do we explain the complexity?
So slightly larger question. I'm debating whether I should larger. So, the complexity of this operation is essentially for any fundamental question like this, your complexity would be essentially complexity of for part 1 plus the complexity of part 2, right? And then you can just break it down. In the start from the most trivial part up, what you'll actually see is that complexity will typically be clearly the complexity is directly proportional to the number of coins you have. You can see, you just look at the proportionality of how the complexity is proportional. Like, what increases the complexity? Is it exponential? Is it logarithmic? And whatnot. In this particular case, it will, I suspect it will essentially be more around the number of times you actually make this operation will be different number of denominations because you're cutting them out quickly. I think it will essentially be n times m or something like that, and I'll have to figure out what the specific thing is. Okay, let's move to the next one, which is permutations without duplicate. So given a string which is print all permutations, and permutations is essentially it doesn't really tell you any more than that in the question. I'm assuming the answer might have some more clues, but essentially you're trying to do, I'm assuming you're trying to do permute of, trying to do the full length permutation, but you could potentially do a partial length permutation as well. So it could essentially be this, okay, where permute of n, taken r characters r letters at a time. So the permutation of this, taking only one character at a time, is A or B or C or D. Taking two characters at a time, it will essentially be AB or BA. It could be, let me do another way. AB, AC, AD, or it could be BA, BC, BD, or it could be CA, CD, CD, or it could be DA, DB, and DC. Right? Two characters at a time. The first character can be ABCD, the second character can be anything else. So the permutation formula, if for those who are mathematically inclined, the number of ways this can be done essentially is
And factorial m over factorial m minus r.
okay. Is it?
NCR.
Is it?
I think this is C. This is C. Yeah.
Why is that extra factorial there?
Because AB and BA are the same.
In that case, the AB and BA are same.
Same.
And that's why the by 2 factorial in that case, right? Because your the R factorial is once you select there are like R factorial ways of actually arranging it. So that's why. So the permutations is this, combination is the one that we talked about, which is n factorial divided by n minus r factorial. And so how do you do this? How do you actually solve this? How many of you have solved it? Awesome. So go ahead.
I have a bad way of solving it, probably. So I'm going back to that binary sequence. So that's how we generated the combination. So now my binary sequence, so there we defined it as 0 indicating whether the element is there and 1 indicating not there and 1 indicating that it is there. So now instead of that, if I have AD, so I'll say if I see a 0, that means I'm looking for the 0th element. So I'm looking for A. If I see 1, then I'm looking for B. So in this case, you get your duplicates as 0, 0, etc. 0, 0, 1, 1. But I'll probably eliminate them. I'll probably, as soon as I encounter a second 0, I'll just look before
So, I know what you're doing, don't do that. Because the specific, don't generate duplicates and eliminate. Don't do that. And even if you want to short circuit, there's probably a smarter way of doing it. So again, think of it as recurrence formula. How would you solve this problem if I know how to generate a permutation of a smaller set? How do I generate a permutation of a larger set is the question.
Start at every letter and then go recursively through the whole array and either leave it or take it.
Either leave it or take it.
And for all sizes, like starting at 1 up to the length of the whole array.
So you're building bottom up. Okay? But why would you?
Yes.
Okay? Might work. So
I can tell you my solution.
let me take a, so one of the simplest ways that I've seen people attack this question is that what can be the first character? It can be either A or a B or a C or a D. Okay?
Yeah.
If the first character is A, what do I have left?
B, C,
B, C, D. So if I want to generate like permutation of the string A, B, C, D, okay, and I want to generate the permutation of length, I'm going to say 2 in this case, right? That's what I want to do. First character can be these things, and what I'm going to do after that is my goal is essentially to generate permutation with B, C, and D of size 1.
Yeah.
Or I'm going to generate A, C, and D of size 1.
Yes.
Right? So essentially what, if I were to put it in a different way, if I have a permutation of like a set of characters, or it's not even set, it's like it's a collection of characters, and then I have K or R in this case, if I want to do that, then what I'm trying to do is I'm going to take like this one element and I'm going to permute this entire thing minus that element, that one element, and R minus 1, right? That's kind of what I'm doing. And till R minus 1, till that R runs out to 0, then if it's 0, then you just return another set and you're golden. That's it, right? So pretty straightforward to do this technique and continue. Now, the question specifically states that the input character does not contain duplicates. What would you do if the input character contains duplicates? That's a very logical extension of the question. So if I, instead of it being A, B, C, D, if I have A, A, B, B, C, C, D, D, and my goal was to generate three-letter permutations. Okay? So AAA is a valid AAB is a valid permutation, correct? AAB is a valid permutation. However, like I'm going to just call it A1 and A2 just to distinguish ourselves. So A1, A2B and A2, A1B are not valid permutations, right? Only one of them should be allowed. Right? You can't just, the positioning of the A's is irrelevant. So how would you do that?
Let's do it the same way we did for the other one. Like eliminate all A's. Like just take A's and the other branch shouldn't have any A's.
You always move forward.
It may or may not work, but go on. Carry on. Let's walk that line. Let's see how that works. How do you do that?
So I assume you have them in a string, which is an array.
Yep. So let's assume that I have a string. So I want to simply make it A, B, B is my string, and I want length 2. Okay.
Okay.
So how do I do it?
So they're sorted, I assume.
Yeah.
Or
Assume
sort them.
And
Okay.
it doesn't have to be sorted, but sure.
So, like I assume that they are an array, and like you have A for the first element.
So-
And okay, so for every other A, just pass the array with like some other special character in it, so you don't take it in the other
So-
next.
Just let me restate my question. That I want to create all 3 letter combinations with this.
Yeah.
Okay. So I take A,
Yeah.
and then I want to solve for A, B, B with 2 more letters, right?
Yes.
That's what I'm trying to do.
Yes.
And what's the other set?
The other set is BB.
Don't take A, is what you're saying.
Yeah.
So no A's and
And BB.
the spelling.
Yeah, that's one for.
Okay.
If we just take B and then
So-
solve,
A and B's are identical. That shouldn't make a difference. One way or the other, whichever you pick.
So you pick a
So first thing is I like the fact that you've taken an existing problem and you're trying applying it to here. So which is good. What we learned, this sounds like a similar looking problem, but it fails, which is good.
Okay, so like a small modification. Don't take AA in the beginning. Take them anywhere else.
Like no,
I mean, like don't like in the other branch. Don't start with A.
don't start with A. Sure. What do I start with?
Start
B.
with-
Of course.
yeah.
That's the only other thing left. So start with B.
AAB.
AAB. Yeah.
So this is not the same type of problem. So essentially, in this example, right, what did we do is we took the element. We are going without the set of elements, right? So in this example, so here, in the same way, you have like you may have 10 A's, 12 B's, and like 100 C's or something. It doesn't matter whether you take A1 or A2 or A3 or A4, right? So just take one A. Solve it only once. So here you only taken one A. And you've solved it once. You will not take A1 and you will not take A2 and solve this. That makes sense?
if all characters count
So
is
it's
greater than
greater
R, then this will work with
No, regardless of, if the number of characters is actually not there, then the answer is not possible.
No, I am saying is all the characters count is greater than the number of count we are looking, then that approach will work, I think.
No, that approach will not work because of how it breaks in certain ways. So let's ignore that approach for now.
Okay.
So here, right, so if I were to apply this original algorithm, then I would have done A1, A2, BB, and I would have done A2 and then A1, BB, and I would have done that, right? That's how I would have done it. The thing is that these items are duplicate, completely duplicates. So what you need to do is, as long as for every unique character, you only do it once. So if you have 2 A's, 2 B's, and 2 C's and 2 D's, you will solve with A plus permutation of essentially A1, B2, C2, and D2, comma, whatever, K minus 1. And you will solve for B plus permut of A2, B1, C2, D2, comma, K minus 1, and so on. So you're only taking each letter, unique letter once for the purpose of for the permutation. So what did we do here was we said, I will take the first letter and then I will solve for R minus 1 permutations using the remaining letters. Then I will take the second letter and I will solve for R minus 1 using the remaining letters. That's what we did, right? So instead of taking the first letter, second letter, third letter, you just have to take unique letters. That's all.
Want to repeat there as well, because you get A and then you can get a B and C and D. In the second one you get B and then A comes and C comes and.
But they're all unique combinations, right? Because
No, won't the ABCD become an ABCD again? In BCDA or something? I mean.
no, you're looking at permutations.
Okay.
So since it's permutations, the first letter A being there happens only like for all these permutations. A is in the first place. We're looking at combinations. So the A is in the first place for all of these combinations. Like all the other permutations, the A is in the first place always. So which means every permutation here is going to be unique compared to every permutation here, compared to every other permutation, and so on. And you are guaranteed to generate other permutations as well because you are reusing the remaining A's anyways in the subsequent problem space.
So for this approach, we first sort the string, or we at least iterated once to calculate how many
Unique characters.
A's we have, how many, not unique characters, but how many.
I would prefer to put it in that map logic that we had, right? like the map, I would like to say how many A's I have, how many B's I have, how many C's I have, and then just use that. That's much easier for me to carry on. And then if you don't do that, then I prefer to sort the string. And then in my for loop, when I'm running through the letters, as long as once I've figured out an A, I will not figure the second character, but I'll actually skip all the A's, and then I'll go to B, and then I'll skip all the remaining B's, and then and so on and so on. Right? Permutation. So knowing how to generate all permutations, knowing generate how all combinations, and essentially this is permutations and combinations are without replacements, and then knowing how to generate permutations with replacements. Permutation with replacement is what? Permutation implies that when I take something out of this file, that goes away, right? A permutation with replacement is basically doesn't go away from the original file. So if I look at, for example, digits, right? So if I have 0 to 9, how do I generate all three number combinations using digits 0 to 9 with replacements? Which essentially means that the answer is you should start 3 zeros to 3 nines. And so this is essentially the input set given to you only has 1 of 0, 1 of 1, 1 of 2, and so on. But as you consume, you are not depleting the source. So this is permutation with replacement. I mean, it's like just a terminology, but the expectation is just that. So these are 3 different algorithms. For most competitive programming, you actually kind of know how to generate it like the back of your hand. You just know how to quickly go ahead and code through it. Should know how to do that, like the N, R. So this is essentially all combinations, right? So in this particular scenario, here the R has to be less than or equal to N. Here it doesn't have to be. Because you can just have 2 digits, for example, like zeros and ones, and if R is like a million, you are generating pretty much like a million bit binary digit essentially, right? All possible combinations. Okay? So,
I think you're beyond the math that most people are familiar with on a day-to-day basis. Quite honestly, the book does it a little bit different way. It's a little bit simpler, which is the way I did it. So it's probably basically the same thing, but
I understand the book has a way of getting through this.
I know the book is weird sometimes with solutions, but sometimes the code is a little odd. But
so my focus here in these sessions at least is trying to find ways to build up from the first principles so that we can apply the same logic for not just solving this one problem at hand, but also solving a host of problems. So permutations with Dup is done. Paint fill is the next one. Flood fill. So flood fill is essentially your goal is to actually color. So given a matrix and each thing is colored with like 2, 3, 4, 1, 0, whatever. So these are all colors, and if you point at something, and I want to make this like color 7, right? That's what I want to do. What you need to do is you need to make all its neighbors 7, and its neighbors, and its neighbors, and so on till you reach a boundary. So that's the expectation. So if you use any graphic application, Paint or Photoshop or something, there is a bucket tool which you can say pick a color and pour it, and essentially just like flood fill the whole thing. So very standard recursion question. How would you solve?
this one is actually a really simple question.
Can be made more complicated, but
I'm sure.
that's the fun part of
How is it
fun edge.
You just figure out the 8 cells around it. You update the 8 cells if they're appropriate.
How are we making assumption of 8?
It's a square. It's grid. It's always a grid. It's going to be.
Why not 4? Northeast, southwest. The question doesn't state that yet.
Yeah, you always say it states that it's a matrix of colors, right?
I understand that, but what define neighbors to me?
Anything that's adjacent.
So define what is adjacent. So
same.
I'm not trying to.
Yeah, I understand.
So these are considered neighbors in some definitions, and
Oh,
these
okay,
are
sorry.
also considered neighbors in some
Sorry,
definitions.
okay.
So it's actually either, you may have 8 neighbors or you may have 4 neighbors, depending on what it is. So number one thing is, I don't know how you want to do this, but in an interview, first is understand the question, seek clarification, make sure that you absolutely understand what the question is about, ask clarifying questions or make assumptions as the case may be. Sometimes the interviewers get annoyed if you keep asking repeated questions, so sometimes you can say, you know what, I'm going to assume that neighbors means 8. So that gives the interviewer an opportunity to come back and say, no, hang in there, 4, right? But if you don't state that assumption saying I'm going to assume the neighbor is 8 and you're going to continue implicitly making that assumption, then I'm going to push back and say, who told you it's 8? And that might just become like a negative flag against you, saying you're making assumptions without actually validating them or clarifying and things like that. So it is always worth stating your assumptions, spend that time to kind of get the meaning of the mind. Okay? Say?
Really good point.
Yeah. So absolutely. So done with that. So now I'm gonna just because you said 8, I'm gonna say it's only 4. Okay? Or maybe the book said 8, so I'm gonna say 4. All right? To me, neighbors mean 4, north, east, south, and west in that sense. Okay? And how do I actually do the fill? Do I actually fill after or do I fill before?
What do you mean by before or after?
Say again?
What do you mean by before or after?
So do I fill first and then fill my neighbors, or do I fill my neighbors and then fill myself?
You normally do it. I think the best way to do it would be
Fill first.
yourself. And
Fill
then
yourself first. Fill first. Fill yourself first.
Because that way we don't have to take care about coming back to the same point after.
It will be marked as visited so that next time it won't be considered in the
You can do
neighbors.
it either way.
No, you don't need a visited set.
I want to complete the debate. Let the debates complete. Go on. Okay.
The 4 would almost be very similar to the 8, except in the corner, except in the kind of the
No,
outside.
4 and 8 has nothing to do with the before and after. They're two
No, I
completely
know. I know.
Okay. So let's assume so let's do 4. Let's do before or after. The question is, do you fill before or do you fill after?
You can do both way, but if you do before, it will be easier to.
So
Why is it easier?
yeah.
Because we don't have to. So if we do after, then you can come back to the same point where you started, going around.
So you need
Then you need to have a
I
mechanism
don't
to
know,
correct.
just go.
Just go to
Yeah,
end.
first,
So
either-
for
either
there's
you
a
go
field,
back to step
then
one.
no
You
color
go
itself.
north,
You can
south.
keep looping back and forth.
Yeah.
Like
If
if
it is
you
a
go,
recursive, you go north, then
You will go south always, right?
you go
Go
north,
north
and
and
north and south.
so hang in there. Let's go one at a time, right? So what I'm saying is that paint of x comma y is what we're trying to do. Okay? So you're going to attempt to paint x minus 1 comma y. You're going to attempt to paint x plus 1 comma y. You will attempt to paint x comma y plus 1. And you will attempt to paint x comma y minus 1. I mean, I'm kind of messing up the order, but you will attempt to paint all the 4.
Right.
One of the reasons why I'm choosing 4 is because it's a lot easier for me to write here on a whiteboard. With 8, sure, you try all x minus 1s and x y plus 1 combinations. Nothing fundamental. So one of the things you want to do is you want to say array of x comma y equals the new color. And then you want to do this. Or you want to put this line in the end.
Yeah.
Right? That's what I was asking for. Now the challenge you have is that you will attempt to paint this guy, right? When would you not paint? When would you not paint x minus y comma 1, x minus 1 comma y?
If it's already printed
When it's not the old color.
Right, you're right. If you paint first, you have to store the old color. That is kind of so that you can check to make sure it's the old color. Because eventually you're going to get the cells that aren't the
Go to
old
one
color.
or the other. So let's
Right.
so how does this work, right? So essentially what he's saying is that if the color that I click like 1, and I want to make 1 to 7, right? That's what I want to do. Correct? So I'm actually saying that I want from 1 make 7 is what I'm going to be passing on anyways. That's a part of my paint operation, right? I want to make all 1s whose neighbors are 1s, I want to make them 7 is what I'm trying to do, right? So when I do this, my first condition is essentially here, my first condition is if a of x comma y is not equals 1, then just return.
Yeah.
So I've done, right? I've done that already. So I don't even, so that's the first step I've done. Now, do I overwrite that with n, or do I do it later? It's a question.
No, you don't.
Does it matter? Does it matter or does it not matter?
It matters
Why does it matter?
because you're doing extra calls.
Again?
You're doing extra calls. You're doing extra calls for extra function calls for every cell that's not that color.
No, no.
I guess technically it would matter.
So doing this if condition
Yeah,
at the beginning
yeah.
is fine. I understand that. If you can do an if condition, you can do 4 if conditions and then only go into the function. That's okay. It's just a recursive depth of 1. Single line code versus repetition of the code. So essentially, this is how you terminate the recursion. It's a very small thing. So that's not my question. My question was this line, which is to set the value. Would I want to put it here or would I want to put it here? That was the question. And I heard it's okay both ways. I want to confirm.
If you want to do at the last, then we need to have another mechanism to track whether we already started from that point or not, basically. So it is
So you
better
need
to do
to,
it
you
from
need
the
to keep track
beginning.
of where you've already been.
Yeah.
Because what's going to happen is if I look at these two guys, right? So with this, from here, I will go x minus 1. I didn't paint this guy yet. From here, I want to go to its neighbors. I will go to x minus 1. I'll also go to x plus 1. So I will revisit the guy I just visited. And there's no way for me to know that that's actually I visited that or not. So I need to have a way of actually keeping track of where I've been. So one of the easiest things you can do is you can actually paint that thing first. And the fact that I painted it will make sure that it is not the old color anymore. It is already the new color. And it works. So there is no do it both ways here. I mean, in this thing, it's like the simplest thing to do is to do it first, like check, paint, and then recursively paint others. Okay, no point in doing it the other way, because you could, if push comes to shove and says no, I want you to paint only afterwards, then you do that. But then I need to keep track of that visited location somehow, and that will be either like a shadow array of like matrix of this where I track the visited, or I'm going to change the color to like a -1 or something to visit. It's like I might as well not change it to -1. I might change it to the right color and call it a day, right? Where will this function fail?
Boundaries,
Where will this fail?
if it goes out of the given.
Fair enough. It will fail for boundaries because we didn't check. We only checked for this, right? So we need to check for like if out of bounds, then return, right? Out of bounds is when like x is less than 0, y is less than 0, x is greater than the max x, y is greater than the max y. So I got to figure that out, okay? Where else will it fail?
If there is no matrix at all.
The matrix is going to be there. So
Are you talking about the case where the color of the cell you're about to paint is not right?
Yeah.
That's the end case.
what's that again?
If the color that you're about to paint, or you're eventually going to get to some that you don't want to replace, right? And
That is fine, right? So that's what it's
Yeah,
saying.
then
I am
it's
checking
alright.
if it's not the old color, then return. So I'll not paint something that's like a 3 or a 5. I'll only replace 1 with a 7. Like I'm passing in the old color and new color as parameters.
Okay, right.
Okay? So in my paint function, I'm passing the old color and new color, and I am checking if this is not old color, then just return.
Oh, if old and new are both same, then
Then what will happen?
so
Yeah.
It will
go
keep-
to an infinite.
it will keep going in infinite loop. So we should.
Are
check
you
it.
sure? The way it's coded.
No, don't just paint it one day. Don't just
Yeah,
just paint the
yeah.
same color one. That's all.
No, it will go to infinite.
It will go in infinite loop.
No,
No, it could not
it
go
won't do anything.
because you can move forward, it might work. The code is right here. I mean, it's not clean, but you guys probably know what the code looks like. So tell me what will happen if the old color is the same as new color. What's the first condition you're checking?
Whether the current point is with the old color or not.
Mm-hmm.
And then we say that if it is not, then go around with all
If
of
it's
it.
equal to the old color, then what do you do?
Replace with the new color. In the
So
beginning.
what have we done? So we had first condition, we check out of bounds, not out of bounds. Old color is new color.
It is.
Is it not equal to old color? It is equal to old color. So it will come to the next one. We'll try to paint it. Okay, let's assume that thing is also old color or new color, doesn't matter. It's also a color. Then it'll again go back recursively in. Is it old color? Yes, still okay, it will continue. And then it will try to paint left, and let's assume that's okay, that's a different color, that's fine. Then it will try to paint x plus 1, which is still the old color, even though you said it. So what will happen?
So it will keep going back and forth, right?
It will keep going back and forth if you have two old colors right next to each other. If you have only one old color or new color, and then you have different colors all around,
That is okay.
then it will not go into an infinite loop. So you kind of technically both correct, but this thing does not have a termination condition because the way the condition is being coded is that if the old color and the new color are the same, and if you have a scenario where there are like two colors which are adjacent to each other which are of the same color and you try to paint this guy, right? What it will do is that it will paint this old as new, which is still the same value. It will go left, it will paint this old as new, which is still the same value, and then it will come back and try to paint this as new as same value, and it will keep repeating because your termination condition relies on the fact that old is not equal to new, right? That's what you're relying on. You're relying on the fact that this a of x comma y actually becomes not O.
Yeah, we can just put the termination condition saying that if the both color are same or not, then we can.
So, let's identify the problem first and then this, right? But does not mean that this will always go to an infinite loop, because if you have a scenario like this, right, it will actually paint that old to new, which is nothing, and then none of the neighbors will work, and it will just get out. So in this case, so it may not, it is not like 100% like a 100% loop, infinite loop, but there are scenarios where this may not be an infinite loop. Again, not something that I would be expecting, but so that's another one. So that is a good catch, where the old and new are the same colors. And it's a very trivial fix. If then is return, right? That's it. If old is new, then do nothing anyways. I mean, it's not going to make any difference anyways.
One of the earlier classes you mentioned that recursion, the stack can go up to only about 200. So, I mean, here that could also be a case where it fails. There's a huge matrix or something.
That was another. So, what happens if this canvas is reasonably large? Your depth of recursion could be significantly high, and you would potentially be overflowing the system stack boundary. Then how do you solve for this?
The stack is like the recursion is so deep.
The recursion is too deep for the system stack.
Okay, why don't you do it like using BFS approach? Where you have a queue and you say
That's another way of doing it. You do BFS.
Yeah.
And in BFS, you identify all your 4 neighbors and find out which neighbor actually has the same color as what I want to replace, like old color, and you just add that to your queue and you're good to go. So you could do BFS
Starting from where?
from the starting point, wherever you started the point. So I am trying to paint from here. Then I want to color this guy. So you color this guy and add all its neighbors which are of color 1, right? So you won't add this color into the queue. Then you go here, you add all its neighbors where so this is not it, 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 so it's only one neighbor. Then the neighbor of this, which is this, and so on, right? So you keep doing the same, it's BFS and it will work. And if you don't use a queue and you use a stack instead, what does that do?
BFS.
Becomes DFS. So regardless, which is more efficient?
BFS.
That was a trick question, but which is more efficient?
Both would.
Well, neither, because it shouldn't matter. Because you are going through every node that has to be painted, you're going to go through it only once. Right? Think of a graph.
BFS, you can enqueue some nodes that don't need to be painted.
In the BFS or DFS?
BFS.
No, you will not. Don't
Maybe you
enqueue.
can check before.
Check before you enqueue.
Okay.
But it's still the same. In recursion also you're doing the same thing, right?
Yeah.
So that variation is actually not significant. So what is it is that it's about if you have to iterate through every node in a graph, which is more effective, DFS or BFS?
Every node.
Doesn't matter. Doesn't matter. I mean, it's the order in which you iterate through that will be different, and how you track visited is a little different, but it's the same thing. So the only difference, I mean, the thing is that in this particular case, you will be visiting every node, you will be coloring every node. So there are probably like a few if conditions that will be different, but that doesn't make a difference. So that's why it was a trick question.
So
Shouldn't do that, but
I have a question.
always
So
helpful to say in front of the board.
They don't use they don't specify the old color and the new color in the initial method. They
You
specify,
don't need the old color because the current color is the old color, right?
they just specify the new color basically
I understand.
in the initial call. and then you check to see if it's already the new color, then you don't do anything at that point in the main call. The question is,
It depends
Would
on,
you-
there's a
would
bunch
you-
of clarifications that need to go into making that. It is actually super convenient to have access to the old and the new colors and you don't have to worry about it. Otherwise, implicitly you can assume that the color that is there before I made change to is the old color.
well, you have, in the recursive call, you have to have two different methods. You have to have a helper method in that.
You may not need to.
Well, unless you do
You pre-check. You pre-check to make sure that the color at x minus 1 and y minus 1 is the old color, and if so, you do the painting. So which means that every method knows that a of x comma y before the function is of old color. You know that for a fact, and you just know the new color you need to set it to. It's just a weird way of doing it. I mean, I prefer being more explicit. It's just a lot easier to think about it.
Well, I think the way the book does it is split into two methods. Right? For the external public method just takes, but my question is, you talked about the case where it cycles.
Mhm.
I'm wondering, I think the way the book does it probably cycles too, but it was that you had.
Maybe not, because if the old color is same as new color, then they won't even go in.
Yeah, it doesn't start the recursion. That's
It
what I
doesn't
was
even
about
start
to
the
say.
recursion.
It is checked in the beginning function where if the target color is same, they don't do anything.
They don't do anything.
Yeah.
You had a question.
So what if the grid is so big to
No, turn false.
maybe you have to read in chunks of those grids?
What if the entire grid doesn't fit in memory?
Yeah, like you have to read portions of it into memory and then start thundering across all the grids. Like the
You're
gap
touching
will be-
into a different area, but let's
Okay.
go do that. Let's go solve that. So what if the entire the space, the memory, right, the matrix, is humongous? We're talking about like a gigapixel image or like a petapixel image, and there's no way your memory can even fit that. Right? You're trying to, I don't know, use like whatever tiny computer with 30 kilobytes of memory to kind of do this. You can't fit the entire thing. So how do you solve for that?
Why do I need the whole image to be in memory in the first place?
You don't.
Yeah.
So typically what I would do is I would like to delegate that to a convenience function. What it will do is essentially move if I'm trying to access something, it should unload what is in memory and load that particular frame that I'm trying to work on, like that grid, in memory, and then I can make a manipulation and it will keep it that way, unless somebody else wants to go in a different way. So let's assume that we are doing this, right? Now, would I prefer DFS or BFS? Because now there's a difference.
You can't
Right.
do DFS in the
But no, why can't I do DFS? I can still do DFS, right? Like the whole point is that my a of x comma y, the way the accessing function for a of x comma y is now a little bit more complicated. All it does is that if x comma y actually is in a grid that is already in memory, then it will continue to use it. If my x comma y is not in memory, then it will unload whatever is in memory and it will load what it needs to load and it will continue. So it's not like it's a completely abstracted away convenience function which doesn't change any of your algorithm. So a BFS will work, a DFS will work exactly the same way it is. But which one would you prefer?
Breadth.
Depth or breadth?
Breadth.
D. Why?
Because the set would be way less than the queue.
More like.
You try to prevent reload.
You
try to
will
prevent
be loading
reload,
more
so you
quick.
optimize
So what are you trying to optimize for? So
your order so that
assuming that's a good point. So I think when I said minimum memory, the immediate bias was to actually minimize the amount of data I'm storing in memory. So the optimization went towards the stack versus a queue. My queue could potentially become gigantic.
Yeah.
Because imagine the entire array vector was like completely free, right? Everything was 1 and I want to make everything 7. So you would see the breadth first search kind of going bigger and bigger and bigger, and I'm just at some point of time the entire circle that represents the whole image will actually be a part of this breadth, the queue, in my BFS. Whereas in the depth first search, essentially, since you're going deep, the farthest point, that is the farthest point away from you, the size of the stack is actually limited by the log n in that case, where n is the number of pixels. So in a way, stack is more effective if that is what you're trying to optimize. But if you're trying to optimize for load, unload, which one would you prefer?
Load,
Breadth.
fine.
Loading and unloading. Like since I don't want to, like the frames are getting loaded and unloaded, right?
that's really
That assuming that is expensive, how do you optimize for loading and unloading of the frame? Would you prefer a breadth first search or a depth first search?
Breadth.
D or B? Depth. Why?
it's going to interact with like the next 4 around it, so that is more likely already loaded, while breadth first is like jumping all around, so the cost will be more. So locality will be better for you.
Fair enough. So I would prefer the depth first search even for that reason, primarily because if you, like the worst case example we talked about, full white page and I'm trying to color it to one thing. So everything is 1, I'm trying to make everything 7, right? And I'm starting from here. Okay? So in the depth first scenario, what happens is it goes x minus 1, x minus 1, x minus 1, it goes all the way here. And as I'm going through this, I'm assuming that this frame got loaded, then this frame got loaded, then this frame, then this frame. So there's still like a bit of loading and unloading that happens because of what I'm trying to do. But once I'm here, it will end up like filling up all of these guys first. Because, not really. It will actually go down. It will actually go down, and then it will go to the right. I'll have to think about how it actually does because it will go through this operation. I still believe the depth first search is better because in breadth first search, since the way this will actually work is it will actually do this plus and it will keep going. Essentially, it's kind of making circles more or less. So as it's going through the circle, it will be loading and unloading different frames as represented by the circle. And since my frames are rectangular, my suspicion is that there's going to be a lot more loading and unloading in a breadth first search scenario than a depth first search scenario.
Why do you need to do this? Why do you need to change the frame to change the pixel? Like, can't you, whenever you reach an edge for a frame, can't you like put in some like queue or something, like do something which is hybrid between DFS and BFS, so that you don't load and unload?
So one of the things you can do is in your breadth first search, if you were to do breadth first search, or even DFS, it doesn't matter which one you pick. Whatever is actually in your yet to be processed, like in a breadth first search makes it a lot more easier. You can just prioritize what is currently in your current frame more than what is not in your current frame. And then what that will do is that will actually prevent any context switches.
Yes.
So with that, a BFS is actually easier to do. If you
It might get a little ugly though.
But you need a lot more logic to know when you
No, it's not that hard, right? I know where I am right now. I know which frame is in memory right now. And looking at everything that I have to do that's in my queue, all I have to figure out is which ones are actually in my frame. And just
Right, yeah, that's easy, right? But what I'm saying is what's tricky is figuring out what to do in the next frame.
I would just go ahead and process everything in my queue that is in the frame that is already in memory. That's it. And just keep processing that. Once I'm done with that, then I just have to pick somebody else, and in that particular case, I just pick anybody. It doesn't matter which one I pick. That's like a subtle optimization. It's not trying to do anything more than that.
Why do you say that DFS would be easier than DFS in this case?
Because DFS doesn't. You don't have all you have. What do you have in memory for DFS?
The node that you're at.
Just all your ancestors.
Yeah.
And you only know your next 4 nodes. That's it. You don't know any more than that. So there's not many things to go with. In a breadth first scenario, I know that assuming I'm here, and this frame is already in memory, and I have all of these guys in my queue, I can prioritize these guys only first, and then prioritize their neighbors first, and so on, to make sure that I'm actually just in my bucket itself, right? Unfortunately, in DFS, you don't have access to that many nodes for you to be able to prioritize them. You don't even know which nodes you're going to go to. BFS, you know which nodes are there, and you have like a large set of nodes that you can prioritize and train. It's again, we are diverging into sort of a whole bunch of hypothetical situations, but good discussion.
The
Okay.
other thing was like, how do you figure out when you go between frames, which one was the one that, how do you pass the memory saying these were the pixels that were, colored just right before this new frame was loaded? Because I guess you'd have to know where to start off in a new frame as well, right?
So that depends on how you want to define your frames. But in general, like if you wanted to have like there's a working area that you keep, which is like essentially a tile of like say 64 by 64 pixels or something like that you're working on, and you know the offset of the current tile in the overall matrix, right? So when you try to load, like when you try to access like 130, 400 or something like that, and that's not in the current memory, then you will unload what you have back to the disk or back to whatever your permanent storage is. You will load what you need from there into the memory, and you will offset with the X and Y that you need, and you should be fine. So You don't keep track of what you have changed, but that's actually what your current frame
But
is.
you have to remember, oh, you mean because you know what the old color is? But what if the image, what if something in the new frame is the old color, but it's not adjacent to an old color from the previous frame?
We still should keep track of the borders, right?
Yeah.
Just the 4 borders, then I think we can, look.
Just by what I'm
Frames
saying,
should overlap by one.
what I'm saying,
You're talking 3 different things. So, 1 second.
So my thought was we have all the frames would overlap by one cell width. So that way, once you change it, you can, well,
So
you
the-
have to actually have a way to set another color if it's in the, I guess, the frame boundary.
Mm-hmm.
And at that point, you recognize whether you need to flip it or not.
See, the challenge that you run into is that in order for me to know, in order for me to even like identify what color it is, I need to unload and reload. If I'm actually at the bottom, if I'm at the leftmost edge of my current frame, in order for me to know whether the person to my left or the rightmost edge of the frame to my left is actually of the right color and should I even color it or not, I need to unload my frame and load that frame. So I might have to do that. So I would, in the BFS example, what I would do is I would essentially blindly add it to the queue and do a post process, not a pre process. Like the example I gave was that I would look for the color. Once the color is right, only then I'll add it. Right?
Yeah.
Now I'm saying I don't want to look for the color. I'm just going to add it. I'll check for it later whenever I get a chance, and that's probably fine. Does that make sense?
So that would also.
right, but how do you know, right, like I was saying, how do you know that the new, you just loaded a new frame, right? How do you know which, but also, there's a starting point in the new frame, right, which is next to the last one, the old frame, is that correct?
There is a point, there are a bunch of points in the breadth first search scenario. I have like 10 points in this current frame that needs coloring, if they are the old color. So I'll go through each one of those points, check if they're old color. If they're old color, paint them,
Right.
and then enqueue their neighbors as well. And if those neighbors happen to be in the current frame, then check and paint them. If they also happen, and then keep repeating that. And if they are of a different frame, then just enqueue them. Don't bother right
No,
now.
I see, so you're keeping the whole, yeah, which is,
So you want to keep the whole queue.
I see what you're doing.
Good.
One quick thing about the recursion is that we might end up having recursion depth of half of the size of the
Correct.
total,
Yeah.
and that is the special case if it is going the spiral.
Mm-hmm.
So suppose we always take a north, up, right, down and left, and then we have a spiral in that same pattern. Then we end up having going till the center and whole thing in the stack. Or
It should be the same
recursion,
case, regardless of
no recursion depth. So,
breadth first also be the same thing.
yes, you also would have the same thing.
Regardless of whichever way you go, right?
Yes.
If your graph is like so, right? Node, right? Then whether regardless of whether you use depth first search or breadth first search,
Size would be.
the depth that you're going to is going to be the same thing anyways, right? The only difference is in breadth first search you only have one element every time. And you unload the element and you go to the next element, right? So you have to go through all the nodes, all the elements, but your BFS will only have size of one. Yeah, right. To 10, and then let's go to excuse me, 13. Stack of boxes. So you have a stack of boxes with box of size like width is width. You have a width, you have a height, you have a depth, and let's assume that the box cannot be rotated. If you can rotate it, it will make it a little interesting. And then what you need to do is you can only stack a box which is smaller than that box in terms of the area, in terms of
The volume, the height is a factor too, you can't
height,
stack.
and the height is so the independent, like all the three factors have to be right.
You can't stack, one of the oddities, there's a couple oddities of this question, and one is that you can't stack a bigger height box on top of a smaller height.
No,
box.
it's a classic. So essentially what you're saying is that so you are expected to stack boxes on top of each other, but this height H1 has to be more than H2, has to be more than H3, has to be more than H4. And specifically the question talks about, so this is width 1, this is width 2, width 3 and width 4. It actually says that the width and the depth, they both have to be less. You can trivialize the problem as just widths. You don't need both. I mean, it doesn't really make a difference.
What I'm saying is that if you were actually stacking up boxes in the real reality, you could not stack a bigger box on top of a smaller box. It would fall off. I mean, assuming that it would be stable. But you certainly could stack
A taller box on top of it.
Yeah.
The different variation of the same question, I believe, is in a later part, which is it's talking about like acrobats. They're like standing on top of each other. So you've got weights and you've got height. So a heavier acrobat cannot stand on top of a lighter acrobat, and a taller acrobat cannot stand on top of a shorter acrobat. Same question.
The other interesting thing.
2 parameters here, 3 parameters in this example.
The other interesting thing is that you can't stack a box of the same size on top of which there's no reason why in the real world you couldn't stack.
Sure. I mean, and those are minor tweaks you can actually change, and it will still work.
Yes, but it changes the method of
A little bit.
code.
All right. So let's do the box stacking. So how do you actually how do you solve for this? Who has solved this? Okay. Anybody else? All right. Okay. What was your attempt?
Basically, or like what the book said as well, like you just go sort them, input array, and then go.
Do you want to sort them by height or do you want to sort them by weight? By width. Let's assume only one dimension. You don't want two, right? Let's do only 2 dimensions. Which one do you want?
Height.
Sort them by height. Okay. Then what do you do?
Well, then you basically, the brute force would actually just be go through all of them. Like you select the first one.
So you want the taller one on the bottom, 7, 5, 3, 1. That's how it is. And the width parameter is. Do you have a reasonable example that we can use? Because I think there are. Fine. So let's assume that this width was like 3, and this width was 5. This width was 4, and this width was 2. Okay. So the answer is
7 and 1.
no 5, 3, 1.
So that what we have to be both.
Yep. 5, 3, 1, right?
Yep.
7 and 1 is 8. Right. 5, 3, 1 is 9.
Oh.
Yeah. So I was just trying to create an example where it's a little 2 different possibilities.
Okay.
So how do you solve this? So is the question clear? So the thing is that this is box 1, this is box 2, this is box 3, and this is box 4. The box 1 is like 7 inches tall, 5 inches tall, whatever feet or whatever you want to use. Units 7, 5, 3, 1 tall, and they are like 3, 5, 4, 2 wide. There is also a depth pattern, but let's ignore one pattern. It doesn't matter which way it is. It just makes it unnecessarily more complicated. That's all. So right now you could essentially put the 7-inch box in the bottom. You cannot put the B2 on top of this because it's wider. You cannot put B3 on top because it's wider. You can put B4 on top. So you can have B1 with B4 on top, which is 4, 7, and 1. Or you can say no B1. I will start with B2. You can put B3 on top of that, and you can put B1 on top of that, because this is 5, this is 3, this is 1, and essentially this is 5, this is 4, this is 2, right? So this is in that order, and this is 3, and this is 2. This is the widths, and this is the heights. And this gives me a total height of 9, this gives me a total height of 8. Clearly B2, B3, B1 wins. B2, B3, B4 wins.
You're trying to construct the maximum height or something?
Maximum height. What is the question?
While the first one, B4 can put on top of B1, the weight is heavier than it, right?
This is a
width
of weight.
Everything has to be smaller.
Smaller. So this number has to be smaller than this for it to be stacked on top. So 5 on top, 4 can come on top of 5. So this is the.
I'm talking about the 8. That's the machine. So width 2 is for B4, right?
So B4 is 2.
Right. And
so 2 can come on top of 3. but 4 and 5 cannot come on top of 3. This has to be in decreasing order always.
Okay.
That's like okay, decreasing or increasing order, whichever way you want to put it. Okay.
So that's basically the way.
So we go. Any challenges with the question? Because I want to make sure you understand the question. Right? Question? Any question with the question? All right. Go ahead.
So I basically, I followed that pattern, but to make it simple, I didn't actually sort the list. So I just basically started with one box. You know, I basically calculated all the possible piles of boxes. And basically when you're piling a box on top of the previous box, you just check to see whether it can be piled on top of it or not. Right? And then once you've made all the piles of boxes, you just find the biggest one. So that's really about it.
You can't necessarily pick the largest box, tallest pipe, right? Tallest box.
No, I started with, you start with all the, you have a pile of one box. Then you have a pile of that one box with any of the ones that are compatible with it above. Right? Then you have another next set of piles, which is all those piles plus, and the other thing to remember is you can only use the box once.
Yep.
That's the trick.
So one of the ways of thinking about this question, I think that the biggest like hint or the biggest like giveaway, which will actually solve this, is essentially trying to identify what is that recurrence problem or what is the sub problem we're trying to solve. So if the data is like so, right? Can you tell me what is the tallest pyramid that you can build that ends with this guy?
This guy by itself.
Ends with 1. What's the tallest pyramid that ends with 1? As in, 1 is in the bottom of the pipe, that's it. There's nothing else on top.
Yeah, this one.
Just 1 itself, right? The reason why this works is because everything to the left of this cannot be put on top of it. The reason why is because this is 3, this is 7, right? So they're taller than 1, so there's no way you can do it. So everything to the right, whatever there is, could come here, for sure. And the tallest pyramid you can build is 1, okay? What's the tallest pyramid you can build that ends with 3? How? Why?
2, right? No. Yeah, 2.
Tallest pyramid is of size 2, total height is 4, right? How did you arrive at that?
Because there was 3 and 1.
So did you use what did you compare? Did you compare this?
That as well.
Don't compare this.
It's
It's already sorted, right? So I know everything on my right is actually fair game, okay? And from a maximal standpoint, first thing is check this with this. That means this is fair game, okay? Let's assume that there was here something which was like, I don't know, half, like 0 doesn't make sense, so half, and that was like, 5 units, heavy, right? So what's the answer for 1? The answer for 1 is still 1, because this cannot be coming on top of this. The answer for this 0.5 is?
1.5.
The 0.5, right? Right? And given that, so let's assume this was not a 4 and a 3, 500, but a 3, then given that this 3 is less than this 4, this is also a fair game. Now, what would you put on top of 3? It can't be 4.5. Because once you put 2 on top of this 4, you can't put this half on top of the 1. So you just have to compare this guy to this to make sure what's fair game, and then use this answer on top of this. So essentially it's 3 plus 1. Just walk with me, okay? What about 5? For 5, what is fair game? So for 5, this is fair game, this is fair game, this is fair game. What's the best of this lot?
8.
This guy, 3 plus 1, right? So which means 5 plus 3 plus 1 is what I can do best here. Okay? For this lot, for this guy, what's fair game? Only this. So what's the best you can do? So the question that I'm trying to ask is, for every box, like if I have to build a pyramid that ends with me, like I am the bottom of the pipe. Okay, can I complete my statement? So the question I'm trying to ask is, if I am the bottom of the pipe, right? What from the right can I actually put on top of me to make it the best? And to figure out what from the right can I make it the best, I'm going to just make sure that figure out which ones are fair game and which ones are not. Right? I only a subset of elements to my right will actually be permitted because there could be things that are wider than me on my right, and if they are, then even though height-wise I can keep them, width-wise I cannot, so throw them out and compare with that, and then you just pick the best of the top and you can put it out there. So the trick here is just that, which is the question you're trying to answer is you're building up from the right, and you're trying to, for every time you know that the best pyramid that I can build which ends with me is this top. And once you figure that out, you can use that to, now if I have an ability to actually stack that on top of something else, then that will be the best pyramid anyways I can do. Right? Okay, go ahead.
From the right, whatever is bigger, I'm going to keep
right, what was
the height for, we are keep calculating the height for the right side elements, right?
of all the elements on the right, because if the pyramid has to end with me, right, then none of the elements to my left can come on top because the height wise it's not going to match.
Okay.
Right? So if the pyramid has to end with 3 as a bottom box, the last box is 3, then none of the boxes to the left will come because the heights are too tall. So I can ignore the left side completely. So I'm only focusing on the right side. So what we have done by this is that you're trying to only, see the recurrence formula here is that you're trying to make sure that I'm trying to only build from one side. That's the only way this will work. Otherwise you have to take like the brute force approach of trying to try every box on top of every box, n combinations, n factorial, and then figure out what you can do that. Right?
What if you devise a matrix and like you start with one box, like the diagonals, like all the indices are the columns and rows, and you start with one box, so all diagonals will be 1. And then
what is in the column, what is in the row?
Indices, start, and rows end, or columns end. Rows start, columns end.
What is the row and what is the column? Is it the height and the weight?
No, the index of the box, like box 1, box 2, box 3.
Walk me through this example. What do I put in the
box
is this 1, 2, 3, 4?
Yeah, indices of the boxes, yeah. 1, 2, 3, 4 as well. Yeah.
1, 2, 3, 4 as well?
Yeah. And then all diagonals would be like element in index 1 and 2, so it starts at 1 and ends at 2.
How? Walk me through the answer. Like, tell me what will be. Give it as an example, what is it?
So
1 and 1 is what?
1 is 1.
Height is 1, okay?
No, not height is 1. True, like this works.
Okay, so 2 and 2 is what?
1, true. True as well.
True.
Yeah.
Yes, it's true.
True. And 3 and 3 true. 4 and 4 true. So you start at index 3 and you end at index 3. So it's true. Like you have only one box.
You don't start at an index and end at an index. Like I don't start at 1 and end at 4. I could actually have, the answer could be 1, 4, 3 and something, right? I could have it that way as well. I mean 1, 4, 3, 2. Right? I'm trying to understand what are you trying to do here. And it's also not start at 1 and end at 4, right? It is essentially, in this example, if I have 1, 2, 3 and 4, the answer is, I mean, it so happens that it's contiguous, but let's assume that there was a 2 with a 100-pound thing here, okay? Then the answer is 2, 3, 5. It's not contiguous. So, this is the longest increasing subsequence problem. Where the longest is not in terms of the count, but it's actually in terms of the summation of the heights, which is a different index. So,
yeah, so this doesn't work.
It's not contiguous.
Yeah.
They're not contiguous. So, I mean, it is always good to try different problems around, but some of these things, right, before you go deep into figuring out how this will work, try to see if you can actually come up with like obvious holes which will invalidate the approach. Like you're making an assumption that all my boxes will be contiguous. And that's not true. Because you can easily come up with an example where it's not contiguous and then you can violate that. Right? So think about that. Break your assumptions and quickly before you even go down the path. In an interview this will be pretty dangerous because you will be walking down a path. The interviewer would have had the luxury of running that question like hundreds of times before you and prior to you, and so they would have known like all the ins and outs, and they would know, I know all the stupid solutions, I know all the good solutions, I know all the crazy outcomes that are potentially there, and they would have spent more time thinking about it. So like very rarely can you actually come up with a solution that works and that surprises me. If it's a question that I've run often, right? So anyway, does that make sense?
Why 3.05 or like 3.5 or 3 plus 0.5 or 5 plus 3 plus 0.5 is an option? It's not an option. Like you can still
Since I was randomly changing the values, I don't know what I did here. But the actual example, let's take this example one more time, right? Let's write the new ones. So 7, 5, let's do that, right? 5, 3, 2, 1 and 0.5, right? So these are the answers. This is what I have. Right? And this is what I have. What's the best pyramid I can build with that ends with 0.5? Okay, this is 0.5. What's the best pyramid I can build with 1?
1.
What's the tallest pyramid I can build with 2? What's the 100? The weight is 100, so nobody else can come. Okay, what's the tallest pyramid I can build with 4? With this 3?
4. 3 plus 1. 4.
This plus this.
Who can sit on top of that?
4.
What's the weight? I want you to give me the answer for this.
3 plus 1.
4?
Yep.
2 can't sit, 0.5 can sit, but the better one is 4, right? Okay, what else?
2 is 100.
Oh, I didn't put the weight here, I think it was 5, right?
Now it's about 5.
8.
Why is it 9?
4.5. Question is forward 5, right?
3 in the sense.
8, 9,
Okay, what is for this?
This
should be 8.
8.
Actually, the things I inserted did not change anything. I didn't know because I was like fiddling with the values. It's very hard for me to keep track of all of that. I thought I inserted the values in a way that doesn't upset the Apple Card. It kind of did. So any concerns with the output? How hard is it to code this up?
I just outright all the element at my right?
You may not have to. Because what you can
the
do,
best from my right.
and how do you figure out the best? You could store all the elements in the right in some sort of a priority queue. If you can store it in a sorted order, then you can keep going down the list and find the first element that actually is compatible with you in terms of the bit.
But in case last element is compatible, still I have to iterate.
Length. So what I will do is at this point, right, I will only keep 0.5 as my, so I'll keep this in my array, in the sorted order. I mean, here it so happens that it's increasing this way, but let's assume that this was like a 6 or something like that, right? If this was higher, I would keep 6, 4, 2 and 0.5 in my queue. When I'm trying to compare with this guy, I know that I need to check 5, so I will check what is the width corresponding to the 6, right? That is 2. If so, then I'll just use it and move on. Because every element below that, even if all of these match, right, will give me lower pyramid height.
Yeah, I agree. But in case all of them are not sitting and beside only 0.5 is sitting, then I have to iterate.
Of course. So, but the convenience that you're trying to get is you store this in a sorted order. In some scenarios, it will actually, I mean, there's a worst case, it will actually be that, but I would keep it in some sort of a sorted order, and I just have to start iterating from the top, go down, and at each point, I just check the corresponding width to make sure that it's all good. So I could do that if I have to, or that's another optimization. I don't care, and I can just go ahead.
Because you are saying we can put everything in a key value, I can check very easily.
Sure. Yeah. Just do a hash map and you're done with it. That just works. Or you could do it in like an array and done with it. Or you could do like a priority queue and then be done with it. So there are different ways you can do it. I think the priority queue will actually is the right answer for this in terms of like the most effective way of doing it. I'd have to think through it.
But it will still be inside.
Why would it be inside?
Because you don't find your root, you're assuming if it's a match, that's your best case. Right?
So the n square will come only if, in the worst case scenario, if I have that and I have this, right, which is essentially Now we know, right? For this case, I have to go through everything every time.
Every time.
So even your heap or the priority queue, so you have to again heapify it, right? So
Every time, you will unlock it, but this is n square anyway. The worst case scenario is this, it will give you n square, even with the heap angle.
I didn't think about it, but I didn't finish the whole. Can we also a solution convert this to a graph, and then become the job depends on another job, and then can come up with maybe the answer. Task the task have more nodes. Basically, using the.
It's not the number of nodes that you're actually trying to optimize for.
But like if we have this dependency graph, then we can get the result from that graph. And that will, because currently we only consider 2 variables, that we can consider whatever variables, right? If we have a class which can sort depending on all the variables, then we can have like a 2D array, like you erase just
You have to think about that a little bit more. So the technique here is not just 2 variables. It can work for any number of variables. The height variable is what is sorted. That's 1. The secondary element, right, that the width that you are sorting can actually be multiple. It could be width and depth and whatever else you want to have on it. Because there, what you're saying is that can this box come on top of this box? Could be based on this. I mean, it could be, you could just say that the area has to be lesser. Only then it can come up. I mean, it doesn't matter what the width is, doesn't matter what the box is. I mean, that's like stupid, but it could be that. Or it could be that the weight has to be smaller and the width has to be smaller and the depth has to be smaller or equal, right? So those are all conditions that are there. So this is just for compatibility's sake. So that could be any number of parameters, not just one. We just took a trivial example, made it simple. So this algorithm will work for any number of dimensions as long as there's only one leading dimension, which is the height. That's what we're trying to optimize on. That makes it easier for us to only focus on one side and not the other side. That was the whole idea of the crux of the problem. The graph issue, I think I understand what you're trying to say. The challenge with the graph is that I see you'll have to construct it to see how that actually works. Because in the example that we had, you'll have 7, which is linked to 1. Then you'll have 5, because 7 is not linked to 5. Then you have 5, which is linked to 3, which is linked to 1. And then you have 2 in the other example. And then you have 5, which is linked to 3, which is also linked to 0.5. And then you will have 2, which is linked to nothing. Because 2 was like, weight was 100. And then you have 1 that is not linked to anything. And then you have 0.5 that is not linked to anything.
Yeah.
Right? So how would I, so this 1 is irrelevant, I guess, because it's already here. Right? And I'm assuming this will be like that.
Right, so just compare 7 to 1 and 5 to 1.
Okay, so now how do I, why would you, where do you start from, where do you end? It's a graph, so where do you start from and where do you end?
So start from 7 or start from 5, right? And then move to the smallest one. So I have an order here, because initially like a solid, and then I will get a true path.
So now what is your, so first is you spent n square trying to construct this graph.
Right.
So you're already done with n square.
Right, yeah.
Okay?
And then I will come up with 7 to 1, this is 1 path, because after 1 that's it. Right? And 5, because it's all like directed.
So you will start with 7, and then you will try to do what? It's not a directed graph. So you try to find the longest chain that you can make with 7.
Right.
And
then when I reach 1, that's done. So I move 7, then I get 5, right?
Well, how do you get 5?
Because after I remove 7, then
Where is 5? Where is this 5? How do you don't start from 7?
I can like in this graph somehow I can know like 7, 5 doesn't have any dependency, so I have these 2 to start with, right? Like a 3 like dependency, I cannot start with 3 or like doesn't. It's not actually.
So that will get you the answer. The complexity of this equation is already n square to begin with from the get-go.
Yeah, this is n square.
Oh.
But then the things I only consider them like the order of consider ones.
No, but it is, to create the graph is n square.
Yes.
So the best case for you is n square.
I mean, worst case also n square.
I understand that. So the other algorithm, the best case was essentially because we only did one sorting, it's n log n.
But I don't know, like within W, if there are several variables, a lot of only one, you still need to consider them like within W, if like a saw, say let's say.
How did you actually decide whether the 7, why is the 7 not linked to 3?
Because after.
You compared the data of 7 with data of 3 and decided that they are not compatible, right?
Because I constructed a graph. I mean,
How did you why is 7 not linked to 3?
Yeah, I do the n square, so I know.
No. Why is this link broken? The link is broken because 7 had a weight of 3 and 3 had a weight of 5, right? And since this is not greater, you can't add this link.
Right.
In the other case, you may have like 3 or 4 or 5 combinations, and they may have 3 or 4 or 5 variables, and you may say none of these things match. That's why this is not there. That's why you did that. So the same comparison will also work in the other algorithm. So I don't think this graph implicitly offers you any greater advantage in terms of flexibility. This graph is another way of solving it, but the construction cost of the graph is n square.
Right.
So the best case and the worst case to find the answer for this is n square.
I'm not saying like it's better than another one. It's just.
No, that's okay. But I'm saying best case is or worst case n square. This also will give you the same answer, because what you've done is essentially you've constructed a graph, and what you've done is in the graph you've constructed the all possible combinations of how the boxes can be stacked are covered here. Which is
it goes through all the combinations.
correct, which is no different from. Actually, this will not work.
We need extra space for this one.
Not only extra space, this will not work in a few cases. Actually, no, it might work because there are cases where I don't know. I have to think about it because if I were to say that at no point of time the cumulative weight can be more than the weight or something. If I actually add some more variations to that, I think it will still make it. It will still work. It will still work. The graph will still work because the graph is nothing more than a more generalized form of what is on top. So this works. Well, it is good. So I think that. Any questions so far?
I have a question.
Go ahead.
So I assume that the brute force method I use is n factorial, right?
Again?
The brute force method I was talking about is n factorial.
How is it n factorial?
Without sorting, so you have to look at all combinations.
So you are looking at
Because you're looking at a lot of permutations.
no, n factorial is the total number of ways in which you can stack n boxes, assuming you take all the n boxes.
It's worse than n.
Fine, it will be n factorial anyways, but it's so you need to go with n factorial is going to n boxes, then plus you have n factorial divided by 2. That's assuming you're taking n minus 1 boxes, and
okay, so it's even worse.
and so on, and essentially by 2 factorial. Because your answer may have just one box, right? So this gives you how to pick n boxes. So you have done essentially what you're trying to do is you're trying to do permute of n for all from 1 to n boxes is what you're going to do. You're not doing permute of n comma n, which is n factorial, is actually worse than that. I think this is like more. There's definitely more than n factorial, but I don't know what that is. It's probably n times n factorial, I guess, or something like that. Or n factorial.
So the other question is, suppose you could rotate the boxes. I was thinking that would.
Suppose you could rotate the boxes. How does that change?
I suspect that at first I thought that meant that
3n.
Well, not as far as factorial. It would just be and that's part of the big O.
This is 3m. Like essentially, you take every box and you just rotate it thrice and add them to the main.
Well, the only issue would be height, or would be boxes of the same size because you still couldn't pile. No matter how many times you rotate boxes of the same size, they're still the same.
No, it's okay. You rotate the boxes and you add them, and then you keep track of the boxes as clusters because once you use the box in one format, you cannot use it in another format. That's all.
Would it just be you just add all the heights together? Assume it, but the problem is both the boxes are the same.
No, if you have a box which is essentially 3, 7, and 2 or something like that, you could use this box as all three, right? The height could be this, height could be this, the height could be this, right?
But I'm talking about width and height, right? In this case, you consider the width and depth, right?
So you have 3 ways of using this box.
No, just 2. I'm saying you can't twist, you can't upside down, you can only twist it this way. Yes, if you could turn it any direction, yeah, then you can do
So I was going with that. That makes it harder.
Okay, yeah, that's true. Okay.
Okay.
Then you can do anything. Right? Then it's easy. Then
Because if you did it, if you could keep the height fixed and the width and the depth could be interchanged, then you use the same algorithm, except that when you're doing the comparison, you just compare for this box, trying to say, can I put this box on top of this, can I take this pyramid and put it on top of this box? You just compare WD and DW.
Right, that's area.
That's it, not area. Both width and depth have to be less than, that's all you're trying to ask for, right?
Right, but if you could rotate it, you could always make it better.
No, the question says can't rotate it, at least this one.
Yeah. Okay, makes sense. I think that that ends what we had for. Was there any other question? I think 13 was the last question, right? Okay. All right. So any questions so far? Any previous questions? Anything that you want to talk about? Anything at all? Any interview questions that folks have been through the recent past that they want to share? We'll take about 15 minutes. We do have. I think I want to stop at about 4ish. So we've got about 15 minutes. So any questions?
I have a question regarding this. There is a capital, there is a seating arrangement, like first row has 6 and 6, next row has 5, 8, 8, something like that. We are getting lot of requests to arrange the seats, something like that. So I have to arrange maximum number of seats, but I have to do front side as much as possible. That's the thing.
You've got stupid seating arrangement in some weird theater where it's not symmetric.
Yeah.
Okay?
Something.
Something like that. Right? You have all of these things, and it has like asymmetric whatnot, and the rules are probably something to the effect of like give as many contiguous seats as possible.
Yes.
Because you just can't like randomly fill people up. Don't split groups.
Yes.
And if you split groups, even if you have to, if you're forced to split groups, then split them in equitably so that there's at least like 2 people in each of the subgroups. So all the rules that are there. So the specifics of the question will actually vary with algorithm. I don't think there is any master algorithm that gets you the answer for this one, as far as I can tell. Anyone has seen this question before? Right? So this is like the theater seating, the bus seating, and the railway reservation, airline seating algorithm. So sometimes they don't do this crazy, they just keep it as very simple. It's like a Boeing thing where it's like 3 on the left, 3 on the right, and 4 seats in the middle, that's it. You've got 10 seats in a row, you've got a portload of seats, and the idea is that you can have people who are reserving for 3 seats at a time. So essentially if they can reserve 3 seats at a time, they can reserve 4 seats at a time, they can reserve 2 seats at a time, and they can reserve like things like 6 or something like that. And when they do, your goal is like a 6 can be split as a 3 plus 3 or can be split as a 4 plus 2. You cannot split them as a 5 and 1. You can't, I mean, not that you can, but you can't split them as a 3 plus 2 plus 1. You can't do that. So go make it happen. There is no good answer because regardless of however you do it, I can change the order in which the booking comes and you will get screwed. I mean, there's no way you can, unless you can reseat people. Then you can probably, figure out a good way of like combining people and whatnot. So the thing to understand here is for such questions, there is essentially a greedy algorithm. Right? A greedy algorithm is essentially if I can make somebody sit somewhere, I'm going to make them sit there.
Okay.
That's what I'm trying to do. And your optimization technique is basically to say that I will actually try to maximize for some value function. So my goal is essentially to, if it's 3, right? I will go make them sit in a 3-seater and call it a day. I'm not going to do anything more than that. I'll make them find a 3-seater, get this person, make them sit there, you're good. That's easy. 4, I'll make them sit in a 4-seater, call it good. Right? Those are all easy. Now if I get one single person to actually book, I don't know where to put them. So my logic right now would be that, you know what, I'm actually going to make them sit in the 4-seater because I get enough 3-seater options to come back, or I may want to eat a 3-seater and give 2 options or something like that. So that makes it The problem is I don't know what to expect. So depending on the data that I have, I might actually do different things. So a few things that are easy to guess, but then other things are impossible. So I think it will be an interviewer question, and I'll have to look at the interviewer today. This is a question that I don't think this is solvable with any typical algorithm that I can think of.
There was an additional condition to the same question, saying that you should allot the maximum possible seats. So we tried the greedy approach.
The greedy approach in most of these cases, right, will not work because
We cannot arrange.
unless you can rearrange, the greedy approach will not work because once you have given the seats away, whatever you have done, right? It's like, for example, if you have to reserve one seat, I have a 3-seater and a 4-seater left. Now what do? Do you actually take that one from the 3-seater or do you want to take the one from the 4-seater? Like, either is not good because if you take one from the 3-seater, I'm going to make another 3% come. Then you'll have to eat 3 of the 4-seaters and now I make another 2% come, you can't do anything now. If you did the other, where you actually made that person sit, then I'm going to bring a party of 4 and you can't do anything with that. So there is always, depending on whichever way you choose, without knowing the future of who's going to come, it's almost impossible to figure out an optimal algorithm.
So is there, I believe this was an online question actually, so is there a way that we can come up with all the possibilities, but
No, not knowing, without knowing the future, I can't. If you tell me exactly the order in which the people have come, then make them sit in the right way, then that's fantastic. Then it's easier. I can sort by largest to smallest, and then try to start accommodating the larger groups first. And then I can, because the smaller groups are easier to accommodate, right? They can fit faster. Like I don't have to seat the ones first, because whatever is left I can sit, I can make the ones sit. So start with the larger group because they are the ones harder to accommodate. So there are like a few different things to think about, but I don't have an answer for it. And answer depends on the specifics of the question. So if you have the actual question wording and the constraints, then we can probably do a lot more with that.
One way would be like you already have the number of people and the number of groups. If you wanted to maximum the number of groups that can be put in this combination.
It depends on the question completely. So good question, but I really doubt there's a good like a golden solve for this.
Can't we accommodate this question with our previous one, like height? Instead of height, we will be putting the number of persons and the weight kind of things.
No, I think the category of the questions are actually completely different. I don't think they are the same space. Yeah. So again, fair call. So one of the things that actually as feedback for everyone is make sure that you're trying to, when you get a question, try to understand the domain of the problem, try to see what it models as, and then try to see if you can apply it. You may be wrong. We've done that a few times where you think, oh, I think this is a problem of that kind. Then you try to break down certain assumptions and then say, oh, I know it's not this category, and then you can try different options. So this one, I don't think it fits in that particular model, at least that's not what, it doesn't click to me. But again, if someone can explain how, then that will work. So in my heuristics, it's not fitting. So I have to figure out how it works. Okay? Alright, so next session, we are actually continuing our week 4 activity. So we're going to do the chat server. And the one thing about the chat server was that this is an object-oriented design question, not a system design question. It's very tempting to actually do the system design for chat server. That's not what we're doing. So we actually have to define objects and the sequence diagrams if you need to, and the class modeling, the attributes, what is the function that and properties and things like that. So that's what we'll do for the chat server. And then I think there is Minesweeper and there's one more that I don't remember the top of my head. There were like 3 questions that I saw. Say again? Parking lot. Oh, okay. All right. I'm like, why? But anyway, all right. So yes, thank you. So yeah, so we'll end up spending some time on those next session. We'll try to dig a little deeper into the chat server. So we will be going through the different interactions and models and stuff like that. And
I have a question about the parking lot.
1 second, let me just close that. And last design session, we actually managed to record it. And even though the phone thing crashed, it somehow was there somewhere in Facebook. So I actually shared it in the Facebook group, and I also posted a link on the Slack. So join the Facebook group. It is linked from our from the meetup. If you're not able to find it, ping me and share where that is.
Is the parking lot question supposed to be to model an actual parking lot or an app to manage a parking lot? That's what I'm trying to figure out.
I don't know what the question actually said. I haven't seen. Yes, anyone know?
Design a
Design a parking lot. Fantastic.
It's very generic. It just says model of parking.
Typically, the model of parking lot, the question is actually around the data that you will have, like what are the different objects and entities that you have, what is the data. So the thing is that I think you need to start thinking about the basic model that you want to have. Like, is it assigned seats or assigned parking, non-assigned parking? Is it like an entry-exit system? When do you pay? How do you calculate it? Like
Right, that would be a parking lot app.
No, that's not necessarily the app, right? It's like the parking lot, the system itself. There's a bunch of things in the system, and there's a bunch of things in the like how do you define the space? What does the space do? Does the space know it's empty, or does the system know that there are spaces available? I mean, these are all like the same kind of questions that we were asking earlier, right? Who knows what? And what is responsible for keeping the state of each of the systems?
Right, so the reason it came up was when I was trying to implement it. Like, if you do is available option, the problem is that if two different car query is available at the same time, they both could get true, but only one could park it, right?
So how do you solve for that?
The problem, so the way
is available. So if I have, so the question is parking lot, there's only one spot available. Okay, I ask the parking lot system, is there space? What's the answer? Okay, another car asks the same question, is it available at the same time? What's the answer?
No.
Right, when you reserve it, it is available, you should reserve it. That was my assessment, but that would be more than a parking lot app. Two cars are just sitting there in the parking lot. One's going to get it, one's going to see what it said.
Yeah, no, so we can design something like, if someone has said, asked is available or has entered that area, you give it 10 or 15 minutes until, at least 5 minutes to get notified that it's taken. If it's not, reserve it for
like
those.
I am at the entrance of the parking lot. You are at the other entrance of the parking lot.
Yeah,
what does it say?
What
does it say? It says one spot available. Or we are in different lanes, right? Same side.
Right,
I will synchronize my is available. So if I say yes to one person, then I would not say yes for another 5 minutes to the other.
And if
I don't like it, reserve it then.
If you don't like,
I don't like the spot.
yeah. So if you don't park and you get out of there, then
I don't even go in, right? So my challenge is this: your is available. It's is available for the purpose of knowing your availability and the purpose of like atomically reserving the is available and reserve are different calls. So let's talk about it. Let's talk about it in the next session. Right? All right. Awesome. Thank you, everyone. Wrap up with the All right. Thanks.
Yeah. Looks like it.